Hello everyone, welcome to this video. In today's video we're going to talk about series in polars. So we're going to talk about the polars library, and first of all we need to import a polars library as PL, and then we would like to learn how to create a series in Python using the polars library from a Python list, from a NumPy array, from an empty series, and with a specific data type. And then we are going to learn how to have the access to elements of a series, and how to do slicing, and how to use the take function. Okay, so first of all, let me give you an introduction of what a series is. So a series in polars is a one-dimensional array that holds a sequence of values of the same data type. It's like a single column in a table or a spreadsheet. So first of all, in order to create a series in polars from a Python list, we call the series from the PL, which is the polars library, and we name it to be age. So edges is the name of the series. Then we are having the list of Python that has these four numbers: 25, 30, 22, and 28. Then this series is assigned to S1, and we are printing S1 in the output. Okay, so when I have the output of S1, we see that it says it's a series of edges, and it's of integer type. It has four elements that are 25, 30, 22, and 28. So as you see, it's a one-dimensional array that holds a sequence of values of the same data types, and the data type here is an integer, and they are in a single column, like in a table or in a spreadsheet, as we mentioned earlier. So you see here we are having our series being created from the Python list. Now I would like to create my series in polars from a NumPy array. But how can I do that? First of all, I'm importing the NumPy library as np, because I would like to create a series in polars using a NumPy array. So this is to create my series. Like before, the series function is called from the PL, then rename it. Then instead of having the list, I'm having the NumPy array. So the array function from the NumPy library is called, and in the square brackets we are having the values 85.5, 90, and 78. And these are all assigned to S2, and we are printing S2. So when I run, we see S2 in the output. So this is S2. It has three elements. It's scores, and it has the data type of float, and these are the elements 85.5, 90, and 78. So the name is scores, it's a float data type, it has three elements, and these are the elements. So far we learned how to create our series in polars from a Python list and a NumPy array. Now let us learn how to create an empty series. So in order to create an empty series, we simply have the series function from the polars library, and we are having its name to be empty, and there is nothing in the square bracket, so it's an empty series. We call it S3, and we print the S3. So when we print the S3, we see that the title is empty, the data type is null, then there are 0 elements in this series, so we see no element here in the output. Then we would like to create a series with specific data types. So here is the series function that is called from polars, and it is called, let's say it is titled to be is passed, and these are the elements, so true, false, and true. These are three elements, and we mentioned that the data type is a boolean. So d type equals boolean, that is called from the PL or polars library. and all of this is assigned to S4, and we are printing S4 in the output. So when I'm looking at the output, we see that there are 3 elements in the is passed series. The data type is Boolean, so we mentioned it will be Boolean because we chose to be Boolean, so pl.boolean, and the type, it is going to simply assign the Boolean to the type of my series that is created using the polars library. Then we are having the outputs that are true, false, and true. So far we learned how to create a series in polars. Now I would like to have another series. So this is my new series called values. This is the name of my series, and these are the elements in the square brackets. So there are 5 elements: 10, 20, 30, 40, and 50. And the series function from the polars library is called to create this series, and all of this is assigned to S. Now I would like to know how I can access to a particular element in the series S. So in the series S, if I want to have the access to the element with index 0, let's say the first element, if I want to access to the first element, I simply write down the print function. I write down the name of the series, which is S, and then in square brackets I have the index of the element that I'm looking for. So the first element I'm looking for it, the first element is the element that I'm looking for it. So the first element index is 0 because we are having the indexing starting from 0. So this is 0, this is 1, this is 2, this is 3, and this is 4. So we see here if we want to access the first element, we are going to have the index 0. So S, and in square brackets 0. So we expect, when I run the code, we expect to see 10 in the output. We see 10 in the output. Then I would like to access the last element, which is 50. Either I can have the index 4 for it, or I can have another way of indexing, because we can index starting from the left hand side or starting from the right side. So I can have the index -1 for 50, -2 for 40, -3 for 30, okay, -4 and -5. So here we see that we can either call the first element, which is number 10, with the index 0 or with the index -5. It's okay, either of them is correct. And we can access the last element either with index 4 or with index -1. So now I'm going to call it with -1. We see the 50 in the output. You see here? So 50 is in the output. But if I, instead of -1, if I write down, for example, 4, we see the same thing in the output. So when I run, we see that the same 50 is out there. So the thing is that here we can do the indexing either way, depending on what your choice is. So we can have the access to the elements of a series using the name of the series, which is S, and in square brackets the index of that particular element. Now we would like to talk about slicing. So in order to access a series of the elements, we can have the slicing. For example, I would like to have number 20, 30, and 40 in the output. So number 20 to 30. So some part of a series I would like to have in the output. How can I access them? I can access them manually here, for example, one by one, or I can have the slicing. So I write down the name of the series, then I would write down from 1 to 4. Why 1 to 4? For 20 to 40. So from 20, the index is 1, so I start at 1. But for 40, the index is 3, but I write down 4 here. Why? Because the ending point is not included. So if I want to include number 40, I need to go to index 4, and because the ending point, which is 4, is not included, it is going to go up to 3 inclusive. Okay, so we are having the slicing from 1 to 4 for 20 to 40. So when I run, we see that here there are 3 elements and they are of integer type, and we are having 20, 30 and 40 in the output. So this is about slicing. And if I want to, for example, have number 10 as well, I can start from 0. So it will start from this number. So when I run, you see the output. So 10, 20, 30, 40. So 10, 20, 30, 40. Now if I want to start from 10 and end at 30, so starting point index 0, so in starting point index 0, ending point index 2, but we need to write down 3, the next following index. Why? The reason is the ending point is not included. So I would write down 3, so it means that we are going to have the index 0, 1 and 2, so 10, 20, 30. So when I run, we see that 10, 20 and 30. Hello everyone, welcome back. In today's video we are going to work with arithmetic operations with polars series. So first of all, I would like to create a series in polars using a Python list. So I call the series from PL, which is the polars. It is called numbers, and there are 3 elements in the Python list, and these are 10, 20 and 30. All of this is assigned to S. Now I would like to perform some arithmetic operations. So I would like to add scalar, meaning that I would like to add 5 value to each element of this series. Okay, so I write down S plus 5. S plus 5 is going to have 10 plus 5, 20 plus 5 and 30 plus 5. So when I run the code, we see the output, the element, the first one, instead of being 10 it's 15, instead of being 20 it's 25, and instead of being 30 it's 35. So now we added 5 value to each element. Now what if I want to have the multiplication to all the elements? I simply write down the name of the series, which is S, and it is multiplied by 2, for example. Now 10 will be 20, 20 will be 40, and 30 will be 60. So you see that all the elements are multiplied by 2. We can multiply by any number. Simply we write down the print function, and in parentheses whatever we write, it is going to be printed in the output. So we write down 10 multiplied by 2, 20 multiplied by 2 and 30 multiplied by 2. Basically this code is going to do that. Then we can have the division as well. So all the elements are divided by, for example, a number, and in this example we are having they are divided by 2. So S divided by 2, so meaning that 10 divided by 2, 20 divided by 2 and 30 divided by 2. So looking at the output, we see that 10 divided by 2 it's 5, the first element. So the first element, 10 divided by 2 it's 5, 20 divided by 2 it's 10, and 30 divided by 2 it's 15. So we see that we are having the division in the output. Now I would like to talk about some element-wise arithmetic with another series. So here we are having the series S2, and these are the elements 1, 2, 3. I would like to have the element-wise arithmetic operation between S2 and the original S. Okay, so in the print function I write down S plus S2. It is possible also. So we are going to have 10 plus 1, 20 plus 2, 30 plus 3. So when I look at the output, 10 plus 1, we see that it's 11. So 10 plus 1, it's 11. 20 plus 2, it's 22. It's 22. Also 30 plus 3, it will be 33. So we see that here it's also possible to add 2 series in polars, and we did that just simply using the element-wise arithmetic. Now we would like to discuss logical operations. How can we do logical operations? For example, I write down s larger than 15, and in the output we are expecting to see false, true, true. But how? So it means that it is going to compare each element one by one by number 15. For example, it says 10. Is it larger than 15? No, therefore the answer is false. 20, is it larger than 15? Yes, the answer is true. 30, is it larger than 15? Yes, and the answer is true. So we look at the output, we see that false, true, true is in the output as we expected. And we would like to have another logical operations here. For example, we would like to have s larger than 15 and s is lower, or let's say smaller than 30 at the same time, because we are having the AND operator. When we are having the AND operator, it means that the condition before AND and the condition after AND, both of them must be true to have the true output. Okay, so even if one of the conditions is true and the other condition is not true, the output will be not true or false, let's say. So it says 10, is it larger than 15? So let me write it down. It says 10 larger than 15. No, it's false. Then on the right hand side we see that 10, is it lower than 30? It's true, but the output will be false because we are having the AND operator. Then we are having 20, is it larger than 15? Yes, it is true. And 20, is it lower than 30? Yes, it's also true, so the output is true. Then we see that we are having the 30. So 30, is it larger than 15? It's true. And 30, is it lower than or equal to 30? So it's true also, so the output is true. So when I made a mistake here. So here it says the last element must be lower than 30 and not lower than or equal. Okay, so 30, is it lower than 30? No, it's false. It's false, so the output will be false. Okay, so we expect to see the false, sorry, let me correct this, false, true, false in the output. Okay, so we expect to see false, true, and false in the output based on our calculation here. So when we go down, we see false, true, and false in the output. So false, true, and false as we expected here. So in this video, we learned how to perform arithmetic operations for a series. We learned how to do the element-wise arithmetic with another series, and we did logical operations. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to learn about some useful functions, or let's say methods, in Python for polars library. So first of all, we import the polars library because it is necessary. We would like to work with this library now. And then we would like to create our series here. So I'm creating my series called S, and these are the elements 5, 10, 15, and 20. I would like to know the sum of the elements. So the sum of elements equals 5 plus 10 plus 15 and plus 20. So what is the output? So 20 plus 10, it will be 30, and 30 plus 15 and 5, it will be 50. Okay, so the sum of the elements in my series is 50, but these are only 4 elements. What if I have a series that has like 100 elements? It's very hard to do it manually, right? So in order to avoid doing things manually, we do the coding, and we need to use the sum function for the S series in order to have the sum. So when I run the code, we see number 50 in the output. Okay, so avoid In order to avoid doing things manually and having the calculation of the sum, you can simply use the sum function. Then we can have the average of these 4 elements. So in order to have the average, now we need to calculate the sum and then divide by the number of elements. We are having 4 elements, so the output will be 12.5. But we can also do that using a function called mean for the S series. So we are going to have 12.5 as the average of these 4 elements, and it is very fast calculated in Python. Then we would like to know what is the maximum number in this series. So the maximum number, as we see here, it's 20. In order to find it, we call the max function for the S series. Therefore, we see that 20 is being printed in the output. Also, we are willing to find the minimum element among these elements in my series S. In order to have that, we call the mean function for the S series, and we see that number 5 is shown here in the output. So these are 4 main useful functions that we can use to calculate the sum, the mean or average, minimum element, and the maximum element. Now, what if I would like to reverse the series? So now it starts with 5 and it ends with 20. I would like to have 20 as the first element, 15 as the second element, 10 as the third element, and 5 as the fourth element. So we call the reverse function for the S series, and when we look at the output, instead of starting from 5, starting with 5, 10, 15, and 20, we see that it starts with 20, 15, 10, and 5. So we used the reverse function in order to reverse our series. Next, we would like to now sort the series. So if we would like to sort the series, we can simply call the sort function for the S series, and we see that we are having the sorted series in the ascending order. So if I add, for example, a few elements here, for example, like 12, like 8, and like 29, and I run the code one more time, and when we sort, we see that now the original series, it's not sorted. Now when I call the sort function, it becomes a sorted series like 5, 8, 10, 12, 15, 20, and 29. So it is sorted in the ascending order. So in this video, we learned about some useful functions called sum, mean, average, and max, mean, and reverse and sort as well. Thank you for watching. Hello everyone, and welcome to this video. In today's video, we would like to have some methods to inspect a series in Polar's library. So first of all, this is my series. It has 3 elements, 1, 2, and 3. In order to create this series, we call the series function from the Polar's library. The name of the series is A, and all of this is assigned to a variable called S. Now, in order to understand what is the name of this series, so I need to write down the variable name, which is s.name. This will help me to have the name of this series, which is A. So when I run the code, because s.name is inside the print, I will see the output and I expect to see A. So I see A because the name is A. So I can change it to, for example, my series. So when I run the code, you see that the name has changed to my series. So this is optional and we can modify it as we wish. Then we would like to know the type of the series. So what are the elements data type? We know that now they are integers, but in order to know it using a method, we can simply write down the s, the name of the variable, dot d type. D type is going to
tell the compiler, okay, I would like to know about the data type of the elements that are inside this series. So when we are using the print function, we see it in the output, we see that it is of integer data type. But what if I change it? So if I write down 1.5, 2.0 and 3.0, for example 3.0, and I run, this time we see that here it says the data type is a float. So here I need to put a comma, not a comma but a dot. So here it says that the data type has changed to a float. So as you see, we can change the values here, and based on the data types that are changing here in the output, we see a different data type as well. So here also we learned that we can have different elements, different data types for our elements, let's say, and the type is going to help us to know the data type of our elements. Then we would like to know the length of our series. So it is easy to calculate it manually now. However, if we are having a very long series with like 100 or more than 200 elements, it's not easy to manually count it. So in this case, we are going to use the len method, or let's say len function, to help us to know the length or let's say the number of elements in this series. So len method is used for the s, and we see that in the output we are having number 3, meaning that there are 3 elements here. So if I add 2 more numbers and I run the code one more time, we see that this is number 5 now. So it has changed. And finally, we would like to check and see if this series is empty or not, and we call the isEmpty method. So if it's empty, it is going to return true. If it's not empty, it is going to return false. So isEmpty method is called for the s. And is it empty? No, the answer is no, because there are some elements here, and therefore we are going to have the false statement in the output. So in this video, we learned how to understand different characteristics of a series in Python that we created using the Polars library. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to create data frame in Polars. So first of all, I'm creating here a data frame from a dictionary. In order to create a data frame, we simply call the data frame function from the Polars library. The name of my data frame is df, and here we are having our data frame. So there are columns name that are keys here. So the keys are here: name, age, and score. So name, age, and score, they are my columns name, or let's say the keys in the dictionary. The values for the name are Alice, Bob, and Charlie. For the age is 25, 32, and 29. For the score is 85.5, 90, and 77.5. So this is the data frame being created from a dictionary. The keys, and because we know that in dictionaries we are having the key value pairs, the keys are name, age, and score, and they're going to be our columns. Then we are having the values here on the right hand side. Then I print the df data frame. When I print them in the output, we see name, age, and score. Then in the column name, we are having Alice, Bob, and Charlie. In the column age, we are having 25, 32, and 29. In the score, we are having the 85.5, 90, and 77.5. So we see that each line is an observation, each row is an observation. For example, in the first row, we see the information for Alice, and this person has 25 years old, and her score is 85.5. So now we learned how to create our data frame from a dictionary. using the key and value pairs. Now we would like to create our we learned how to create our data frame using a dictionary here. Now I would like to create my data frame using a NumPy array. So first of all, I'm going to import the necessary libraries. So I'm going to work with polars and NumPy, so I import them. Then I have my NumPy array. So the array function is called from the NumPy library to have my NumPy array. You see that there are here, this is one row, this is another row, and this is another row, okay, because there are different square brackets. So this is the information for the first row, this is the information for the second row, this is the information for the third row, and in each row we see that there are two data, so 1 and 2, meaning that we are going to have two columns, because in each row, when we are having only two numbers, it means that we are having two columns. So this is my NumPy array being initialized, and the name is array. The name of it is array. Then I would like to create my data frame. So I call the data frame function from the polars library, which is here. And then I would like to create the data frame from the array, which is this one. And this array is the name of my NumPy array. And we would like to have the columns name to be col1 and col2. So col1 and col2. When we print the data frame in the output, we see that col1 and col2. We see that here we are having in the first row, we are having 1 and 2 as we expected, 1 and 2 in the first row. So 1 is in the first column, 2 is in the second column, 3 and 4. So this is the second row. And we see 3 is in the first column, 4 is in the second column, and 5 and 6 as well as the last row that we see here. For example, if we wanted to have 3 columns, we just needed to add another number here. So I add a 2 here and a 2 in the last row, and also here I would simply add the title of my column. So when I run the code, now we see that we are having 3 columns, okay, and 3 rows, because there are 3 pieces of the information. So this is the first row, second row, and the third row. So first row, second row, and the third row. And in the first row, we see that there are 3 numbers, meaning that we are having 3 columns. Again, here the same thing happens, the same thing happens here. And we are having the first column, second column, and the third column titles that are called 1, 2, and 3. So we see call 1, call 2, and call 3 here in the output. So in this video, we learned how to create our polars data frame from a NumPy array and also from a dictionary. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to get some information from our data frame. So this is my data frame being created from a dictionary. The keys for the dictionary are name, age, and score, and the values are Alice, Bob, Charlie. 25, 32, and 29 are the ages. And also we see that scores are these numbers. So first of all, I'm going to print the data frame. So when I print the data frame, we see the information in the output. We are having a 3 by 3 data frame, meaning that we are having 3 rows and 3 columns. And then I can inspect my data frame, meaning that I can have some information about my data frame. First of all, in order to know the names that are list of columns name, let's say, in order to have that, we call the name of the data frame, which is df, and then dot columns. This is going to help me to have the name of the columns in the output, but we need to put it in the print parentheses. So when we look at the output, we see name, age, and score. We see name, age, and score in the output. So this is the first way to inspect our data frame, so we can know the list of column names. Then we can understand the data type. So when I run the code, we see that string, integer, float. So string is because we are having the first column, which is name, as a string. The second column, which is age, as integer. and the last column score as to be float. So we are going to have the df.dtypes to have the data type of our float. Of our data frame. So when I want to know the number of rows and the number of columns, we call the shape. So df.shape is going to help me to have the number of rows and the number of columns. So I'm having 3 rows and 3 columns. We see that here. We can simply inspect that using the shape method here. Then we can also know the number of rows individually. So df.height is going to give me number 3. If I was having something like more than 3, I was going to have this number being changed. For example, if I add a new row here, so I would add Reza 33 and score to be 95, for example, and when I run one more time, here we see that we are having number 4 as the number of rows. So number of rows now has become 4, and Reza also added to my data frame here. So the next thing is to know the number of columns. So when I run the code, this time I get number 3 because I have 1 column, 2 columns, and 3 columns. So there are 3 columns here. We see, so df.width is there, so number 3 is being printed in the output. And then we can have, for example, the head method to know the first n rows. For example, now I would like to know the first 2 rows, and I run the code, and we see that Alice and Bob, their information is there because I would like to know only the first 2 rows. So head method and then the number of rows that we are looking for, we can have them there. And in the print function, we are having the df.head, and then inside parentheses, we have the number of rows that we would like to have. So the first 2 rows, they're being printed here in the output. But what if I would like to have for example, the last 2 rows? In order to have the last 2 rows, I use the tail function. So the tail function, when I run, is going to help me to have the last 2 rows because I put number 2 there. So Charlie and Reza information, their information is being printed here in the output as they are the last 2 rows. And finally, in this inspecting stage of our data frame, we can have the describe method to give us a summary of the statistics of our data frame. So for example, it is going to tell me how many values are there in the name column, in the age column, in the score column. We see here, and we are going to see how many missing values do we have. Because we don't have any missing values, the numbers are 0. We see about the mean, standard deviation, minimum, maximum, and here, for example, we see that 25% of the numbers are these for age and score. So the quartile, the first quartile is for age is 29, for the score is 85.5, for example. Then 50, or let's say the second quartile, or let's say the median is number 32 for the age, and for the score it's 90. And then we are having the third quartile, or let's say 75%, and finally the maximum, which is the information regarding the Reza, and the minimum is the information with respect to Alice. So in this video, we learned how to inspect the data and information of our data frame. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about how we can select columns in polars. So first of all, here is my, let me remove this line. Here is my data frame being created here. So the data frame name is df. I call the data frame function from the polars library. and I'm creating my data frame from a dictionary, and this dictionary has name, age, and score. So these are the keys, and the values are Ali, Sarah, and Reza. The values for age are 25, 30, and 22, and the values for score are 85, 92, and 78. Now I would like to only call the name column. So I use the print function, and then in parentheses I have the name of my data frame, which is df, and then in square brackets in quotes I'm having the name of the column that I'm looking for. So I would like to have the column name being printed, so I write it down here, and I have the name of the data frame before that. So when I run, we see that here we are having the information that are stored in the name. So first of all, let me print the data frame itself. So when I run, so this is my data frame itself. So in the name column, I'm having Ali, Sarah, Reza. In the age, we are having 20, 25, 30, and 22. In the score, we are having 85, 92, and 78. Now, this is my data frame. I would like to only have the information of the name column being printed. So I call the name column from the df data frame, and I'm printing it. So we see that Ali, Sarah, and Reza, these three names are being printed in the output. This is one way. This is one way that we use a bracket. We call it bracket notation. So we are having a square bracket, and there we are having the name of the column that we are looking for. Then we are having the name of the data frame, and we are having the print function to print them in the output. The second method is to use the select function, or let's say it's select method, that returns a data frame. So for example, I have the select function for the column name from the df data frame, and I'm going to print it. So it is going to bring the whole column for me. So then from here, everything from name, starting from name going down up until we reach Reza, is being printed here in the output. So name, and we see Ali, Sarah, and Reza, they're being printed here. So it's a new data frame that has 3 rows, one Ali, Sarah, and Reza, and one column that we see here in the output. So this is the second method. And the third method is to use the get column method, or let's say function, to give us a new series. For example, I would like to have the score column. So I call the get column method for the score column from the df data frame, and I use the print function to print it in the output. And we see that the values that are in the score column, 85, 92, and 78, they are being printed here in the output. So 85, 92, and 78, they are being printed in the output. So in this video, we learned how to create a data frame from a dictionary, and we learned 3 methods to filter based on the columns. We learned the bracket notation, so we write down the name of the column in the square brackets, and then before the square brackets we are having the name of the data frame. We learned about the select function to select a column from our specific data frame, and also we learned about the get column function that is going to help us to have the filtering by the columns. Thank you for watching. Hello everyone, welcome back. In today's video we're going to learn how to select rows. So here we are having our data frame being created from a dictionary. The name of my data frame is df, and in order to create it I call the data frame function from the Polars library. We are having 3 keys here because this is my dictionary, and in dictionary we are having the key value pairs. So my keys are name, age, and score, and these are the corresponding values, okay, for each key. Now first of all I'm going to print the data frame df. So I print the data frame df, and we see here in the output we are having my data frame being created. So the information are there. The information is there for Ali, Sarah, and Reza. So we see that for Ali, Sarah, and Reza. So Ali is 25 years old and could get the score of 85. Okay, you see here the same information for Sarah, and the corresponding information for Reza is also there. Then, in order to simply call the first row, for example, Ali, we would like to print only the Ali's information. We write down the name of the data frame, and in square brackets we use the indexing. So index 0 is for the first row. So the first row is having the index 0, second row index 1, third row index 2. So we use actually the index 0 for the first row, and we see that the Ali's information is being printed here. But if I want the information of Sarah, simply I write down the index 1 and I run the code, and we see that here Sarah's information is being printed. And if I want the information for Reza, for example, I write down the index 2 and Reza's information is being printed. Something to be careful about here is simply just to know that the indexing starts from 0. So the first row has the index 0, second row index 1, third row index 2, etc. until the end. So this is the one method that we can select the rows. Another way to select rows is to have the slicing. So when I run the code now, you see this example. Ali and Sarah, they are being printed in the output. So we are having the first two rows being printed in the output, meaning that I'm having the rows from index 0 until index 2, but 2 is exclusive, it's not included. So the starting point is included, meaning that we are going to start from the index 0, which is Ali, and Ali is there. However, the ending index is not included, meaning that when we write down index 2, the information regarding the index 2 is not there, is not included, and we are going to have up until index 1 included. So 0 and 1, the first two rows are being printed here, Ali and Sarah. Their information is being printed in the output. So this is how we can have the first two rows. And if we want to have the last two rows, for example, Sarah and Reza, we simply do the same thing. However, we need to have -2 colon, meaning that, okay, give me the last two rows. Then we are going to have Sarah and Reza in the output. So you see that the last two rows are Sarah and Reza. This is how also we can access the rows, or let's say the filter by rows. Another way is the fact that we can have some filtering. So for example, we would like to have the age people whose age are more than 24. So this is my original data frame. I would like to filter this data frame based on this condition. So I would like to only have the information of people who are older than 24, and I would like to have their information in my new filtered data frame. Okay, you see here in the output. In order to do that, I call the df function for the I call the filter function for the df data frame, and simply I write down the call, or let's say column. It represents the column. So we call the call method from the polars library, and because we would like to have the condition on the age column, we write down age here. And then the condition, for example, we would like to filter people whose age are larger, or let's say bigger than 24. They are older than 24, and we are having the condition on the age column using the polars library, and all of this is going to return a new data frame for me, and that data frame is assigned to filtered variable. So the name of my data frame is filtered. Then I print filtered, and when I look at the filtered, we see that only two people are being printed in the output, and their age is indeed larger than 24. If I want to have condition on the score, for example, column and the score column, I would like to have people whose score is larger or higher than 90. So when I run the code, I see only Sarah in the output because Sarah is the only one who could earn a score larger than 90. Okay, so this is how we can have the conditions in the output. Or we can have the, for example, if you're having a list with 200 rows, you can have the filtration based on the names. So for example, you would like to print information regarding people whose names are John, and only you would like to find the Johns in your company or in your data frame or databases or data set, etc. So this is also how we can filter the data. We can also have multiple conditions. For example, we could have this condition saying that, okay, I would like to have the age to be larger than 24 and also their score must be larger than or equal to 85 at the same time. So people who are older than 24, okay, and could get a score that is higher than 85. So two conditions are there. So we are having the AND operator, and we see here we are having the people being printed in the output whose ages are more than 24, and also their score is larger than 85. So again, Reza is being filtered because he neither is older than 24 nor he could get more than 85. But if I change the age of Reza, so instead of 22 now Reza is 33, so Reza passes the age condition, but still he does not pass the score condition, you see, and Reza is not there in the output. So now Reza is 33 years old, so he passes the first condition, so he is older than 24, but his score is 78 and he could not get more than 85. Therefore, we cannot have him in the output because we are having the AND operator here. Both conditions must be true, so we could have them in the output. So in this video, we learned how to select rows or access specific rows. For example, the first two rows or the last two rows, we learned how to filter information in one column. For example, people who are older than 24 or who could get a score larger than 90. And we learned how we can have multiple conditions to only target people that we are looking for. Thank you for watching.
Hello everyone, welcome to this video. In this video, we are going to learn about the call function from Pandas library. It is used for selecting or referencing a column. So first of all, I'm importing the polars library because we would like to work with it. Then I would like to create my data frame from a dictionary. This is my dictionary. In order to create my data frame, I call the data frame function from the Pandas library. The name of my data frame is df. Then this is my dictionary, and we know that in a dictionary we are having key value pairs. So keys are name, age, and score. The values are Ali, Sarah, and Reza for this key. The values for age is 25, 30, and 22, and the values for score is 85, 92, and 78. So first of all, I run the code and I print the df data frame. So we are having our df data frame here. We see that there are three columns: name, age, and score. Then in each row we are seeing the one observation, for example. So in the first row we see the information for Ali. In the second row we see the observation for the Sarah, or let's say the information for Sarah. She's 30 years old with the score of 92, and this is the score, this is the information with respect to Reza. So now if I want to select only a single column, I simply need to use the select function and then choose the column that I would like to be displayed. So I have the select function for the df data frame, and in the df data frame I would like to only have the score column being selected. Okay, so when I have this code, I see this is the output. So this column is the score column. It is this column. Okay, this is this column, score. So 85, 92, and 78 is there. These three numbers are there. And now I would like to have only the column score from the df data frame. Now when I have this line of code, we see this is my output. So score 85, 92, and 78. All of them are being printed here in the output. So I learned now using the select function and using the call function, call I mean, we can select to display only one column of the df data frame. So this is the first thing that we wanted to learn. And the second thing that I would like to learn is the following. So first of all, let me run the code. When I run the code with this newly added line, we see this in the output. So basically this is my original data frame. Basically I see name, age, and score. Their columns are there. So name, age, and score. However, we are having a new column being added. It is called score plus 5. How did I do that? So first of all, we have the with column function for the df data frame, and this with column function adds a new column to the data frame without modifying the original one, and returns a new data frame. Okay, so it is not going to modify the original data frame, which is this one. It is going to basically return a new data frame. So we call the with column function for the df data frame, and there we are having the column score, and we would like to have 5 unit being added to the column score and to be placed in a new column called score plus 5. So score plus 5 is the name that we would like to give to the new column. So score plus 5 is here, and using the alias function, actually we are giving the name to the resulting expression, which is the new column, and this new column is being created with this name. Okay, so I have the alias function to create a new column with this title, and this is the title of the column. But what do we do about the elements that needs to be filled? In order to fill the elements, simply we take the score column of the original data frame, and we add 5 values to the score column, and we put it in the score plus 5. Okay, so here we see that in the original data frame, score for Ali is 85, which is here, score 85 for Ali, but now it's 90. Score for Sarah is 92, but now it's 97. Score for Reza is 78, and now it's 83. So we see that we created a new column. The title is chosen by the function alias, and it is filled using this line. So we take the values of the score column and add 5 unit to those values, and all of these are done thanks to the with column function, which is going to return us a new data frame, and it's not going to modify the original one, and it is going to help us to add a new column with this title. Okay, and these are the values. So in this video we learned how to work with the select function, the call function, and also a with columns function. Thank you for watching. Hello everyone, welcome back. In today's video we are going to work with the lit or lit function, and also we are going to have combination of the usage of lit function with underscore columns function. So first of all, I create my data frame in polars. In order to create my data frame, I call the data frame function from the polars library. I call my data frame df, and I create my data frame in this example from a dictionary. We know that in dictionaries we are having key value pairs. These are my keys: name, age, score. And these are my values: Ali, Sarah, and Reza, 25, 30, and 22, 85, 92, and 78. So first of all, I print my original data frame. So this is my original data frame, and we see that we are having 3 rows and 3 columns. So the first row is for the information for Ali, the second one is for Sarah, the third one is for Reza, and this is the original data frame. Now I would like to add a constant column. So let me show you the output first. So when I run the code now, you see that here I'm having the original data frame with name, age, and score columns. So name, age, and score columns. Then we are having a new column called group being added here. The group is being added here with the constant a. Everywhere we are having a. Okay, but how can I do that? In order to do that, in order to add a new column, we use the with column function for the df data frame. And in parentheses, basically, we are saying that, okay, name the new column to be group. So group is the name of my new column. And fill this newly generated column with a constant a. Meaning that, for example, the score that they got, it's the A grade. It's grade A. And it's the use of literal value that we are having here, lit function or lit function. It's for literal value, let's say scalar constant. So here we learned how to have the with columns function to let us add a new column to our data frame, but it's not going to modify the original data frame. It is going to create a copy of it and do the modification on the copy. Then we named the new column to be group, and then we were having the literal value a. So we are adding a new column. You see here we are still having 3 rows, Ali, Sarah, and Reza, and 4 columns: name, age, score, and group. So this is the first thing that we wanted to discuss. But the second thing here is the following. So now I would like to again use the with column function. So because I would like to add a new column, and this new column, I would like the name of this new column to be boosted score. So when I run the code, you see that the title of the new column is boosted score, thanks to the alias. And then I would like to fill the column that I just generated. In order to fill that with some numerical values, I would like to have the score column data and add 10 value to them. So I can use the lit function to add one value, like one unique number to them, and this unique number is 10 here. So we see that here, for example, the boosted score is 95 for Ali, while the original score was 85. So 102, 92, 88, and 78. So here we see that with using the with columns function, we can add a new column, and using the alias, I choose the title, and here I choose to have the values of the score column in the original data frame and add a constant of 10 to it. Okay, so we see that here we are having it in the output. So in this video, we learned how to work with the lit function and combine it with the with columns function. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to work with several functions in Pandas: call, lit, and when function together, all of them in one example. So first of all, I would like to create my data frame. In order to do that, I call the data frame function from the polars library. I call my data frame to be df, and this data frame is being created from a dictionary, and this dictionary has 3 keys: name, age, and score. And each key has its corresponding values. For example, Ali, Sarah, and Reza are the values for the key name. 25, 30, and 22 are the values for the age key, and 85, 92, and 78 are the values for the score key. So first of all, I print the original data frame. So we see that this is my data frame. We are having the name column, we are having the age column, we are having the score column as well. And each row is one observation. So the first row is for Ali's information. So the name of the person is Ali. This person is 25 years old and has a score of 85. Then we are having Sarah, and then we are having Reza. Now I would like to do a little bit of changing. Well, let's see the output first, and then we learn how to have it done, make it done, finish it. So you see that here I'm having the first three columns. They are the same as the original data frame. However, the fourth column, which is called age group, we see that it is newly added. And for the first two rows, it is having the value adult. And for the last row, it has the string young. Let's say there are three strings. The first two ones are adults. Then the last one is young. We would like to know how to do it, but we don't want to do it manually. So we don't want to do it manually and add it here. We don't want to type it down. We would like to write a code that it does everything here automatically. So in order to do that, because we would like to add a new column, we call the with columns function for the df data frame. So this is the original data frame, and we call it df again. So we are going to have a new column for the df data frame, and we can name it however we want. We can have it the df2, and then here I would also have df2. So when I run the code, we see no changes. So because I would like to add a new column, I call the with columns function for the df data frame, which is the first one, and we call it data frame 2. So df2 is my new data frame that is created from the original data frame that is called df, and we are going to do some changes and modification to it. Okay, so we're going to get the data from the df data frame, but we're going to, because we would like to add a new column, we're going to check some stuff to fill the new column. So first of all, we're going to say, okay, we would like to add a new column, and because we would like to add a new column, we write the with columns there. So we call the with columns function. Then, because I would like to name my new column to be age group, I use the alias function and call it age group. So this is the title. How do we fill this? How do we fill the information here? Now I would like to have this condition. So when looking at the age column, when the age of that person is lower than 25, then you should write down young in the new column. Otherwise, write down adult. So this is the translation of this code. So first of all, naming the column age group. Then when we are telling the compiler, when you're looking at the age column in the original data frame and the age is lower than 25, okay, then write down the young string in the age group column corresponding to that person. So for example, Reza is 22. Now this person, the age of this person is lower than 25. Yes, then put young here. Otherwise, meaning that if the age is larger than, or the age is older than 25, put adult. So Ali is 25, Sarah is like 30, so we are having adults here being printed. So in order to check the condition, we use the when function. So when you see this condition, when you face this condition, then do this. And to put young, we use the lit function because it's a constant. We learned that we are going to use the lit function, meaning a literal value. Otherwise, meaning that if this condition was not true, otherwise lit, or let's say write the adult and name the column to be age group, and finally print the data frame 2. So in this video we learned how we can have a data frame. First of all, how to create a data frame. Then we learned how we can create a new data frame from the current data frame and add a new column to that. So we added the age group column and fill it with two new strings, either young or adult. So if the person is younger than 25 years old, we are going to have the young in the output. If the person is older than 25, we are going to have the adult being printed here in the output. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to practice conditional assignment with multiple branches. So first of all, I would like to create a data frame. This is my data frame, but I would like to create it. How can I do that? I have 3 columns, name, age, and score, and 3 rows. Ali, Sarah, and Reza, they are the 3 rows that we are having here. In order to create our data frame, we need to call the data frame function from the Polars library, and I called my data frame to be df. We are having the data frame being created from a dictionary, and this dictionary, we know we are having key value pairs, so name, age, and score. These are the keys, and values are Ali, Sarah, Reza, 25, 30, 22, and 85, 92, and 78. So for example, the value for the key name, these are the 3 values. These are the 3 corresponding values for the age, and these are the 3 corresponding values for the score. Now I would like to print my data frame. So we created a data frame from 3 keys and their corresponding values, and I would like to print the df data frame. So when I print them, we see it here. We're having name, age, and score, and each row is an observation. For example, the first row is the information of Ali. Ali is 25 years old and he could score 85. The same with Sarah. The second row is the Sarah's information, and the third row is the Reza's information. Then I would like to create another data frame from this data frame, and I would like to add some values to it. So let's see the output first, and then we learn how to do it. You see, this is my this is my second data frame. It has 3 rows and 4 columns. So 3 rows, Ali, Sarah, and Reza, and 4 columns, name, age, score, and grade. So we are having 4 columns here. So the first 3 columns are the same as the first data frame. We have no changes to be done then. We are simply having them here, but we are adding a new column called grade, and we see that for Ali it is B, so the grade of Ali is B, the grade of Sarah is A, and the grade of Reza is C. Okay, now we would like to add this column called grade, but because we would like to add this new column, we need to have some evaluation. Because we would like to have the grades, we need to evaluate the scores based on which we are going to generate the grade. Okay, so here I would like to call the with columns function, because I would like to add a new column, and I am adding a new column to the df data frame that we originally have, but we know that the with column function is not going to directly modify the original df data frame. It is going to modify a copy of it, not the original version, and the copy version is assigned to df2. Okay, so the with columns is called, so we know that this function is going to help us to add a new column. Now that I call the with columns function, first of all, I have the alias. Okay, the grade is the title of this column, so I have the alias function to put the title for this column. So I have the grade. So in the end, we know that we need to have the grade, but how can we have the other grades, A, B, C, D? For that, we need to have the conditions. So we call the when function from the Polars library. So when, we are telling the compiler, when looking at the score column and the score is larger than or equal to 90, then put A in the column grade using the lit function. So using the lit function, we can add a constant. So if the score of a student is larger than or equal to 90, put A in the grade column. Okay, when the score of the student that is shown in the score column is larger than or equal to 80, you need to put B, then put B using the lit function. When the score of that student is larger than or equal to 70, then put C. Okay, put C using the lit function. Otherwise, if none of the above conditions is true, otherwise put D. It's like the else part of an if statement, if you remember. So we were having if, elif, 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 else. Else is going to be activated when neither of the above mentioned condition is true. Okay, so otherwise, meaning that if the score is not larger than 70, 80, or 90, simply write the grade D in the column. So looking at the, and then when all of these modifications are done, we're going to assign them to df2, and we print the df2 that we see here in the output. Okay, so looking at the alias information, first of all, the compiler starts with the ali, for example. It checks to see if his score is larger than or equal to 90. Is it true? No, because he got 85. So it goes to the next condition. Score, is it larger than or equal to 80? Yes. Then put B in the grade column. So we see that B is here. For Sarah, she could get the score of 92. So 92, is it larger than or equal to 90? Yes. Then, because this is true, then put A in the grade column for Sarah. So we are having A here. Then we are having the Reza here with the score of 78. And so 78, is it larger than or equal to 90? No. Is it larger than or equal to 80? No. Is it larger than or equal to 70? Yes, because it was 78. So when this is true, then put C in the grade column for Reza. So we see that here we are having the C we are having the C in the grade column for Reza. So basically in this video we learned how to add a new column to an already existing data frame, and first of all make a copy of the original data frame and do the modification to the copied version. Then with the copied version we learned how to add a new column and fill it with certain conditions based on an already existing column called here score. So based on the score column, we added a new column called grade, and the grade column was going to get any of these values between A to D. So A, B, C, and D, depending on what the score of the student was. So in this video, we learned how to have multiple branches of conditional assignment. Thank you for watching. Hello everyone, welcome to this video. In this video, we're going to learn how to perform basic arithmetic operations for our data frame with different columns in polars. First of all, we're going to import polars library as PL because we would like to work with this library, so we need to import it. Then we would like to create our data frame. In order to create our data frame, we call the data frame function from the polars library. I name my data frame to be df, and here I have two keys called A and B and their corresponding values. 1, 2, 3 are the values for the key A, and 4, 5, 6 are the values for key B. So here I created my data frame df. Now I would like to first of all print this df data frame. So when I run the code, this is my data frame. This is my original data frame. Here we see that we are having 3 rows and 2 columns. So you see here 3 rows and 2 columns. So the first row is A, you see here. So this is the first column, and this is the second column called B. So this is the first column called A, this is the second column called B. The data in the A column is 1, 2, 3. So we're having 1, 2, 3. The data in B is 4, 5, 6. So 4, 5, 6, we're having it here. So here I created my data frame. In the first row, I'm having 1 and 4. The second row, I'm having 2 and 5. In the third row, I'm having 3 and 6. And the first column is called A. The second column is called B. So we are having 3 rows and 2 columns. Now, first of all, let me show you the output table, or let's say data frame, and then I will tell you how we can reach that data frame. So this is my output data frame. So this is what I'm aiming for. I would like to get to this data frame, but how can I do this? So as we see, the first 2 columns are the same columns as the original data frame A and B, but we are having a few more columns. So 5 new columns are added called sum, difference, product, division, and modulus. Okay, so these are the new columns that are added. For the sum column, we see that we are having in the first row number 5, which is the A plus 4, so it is 5. Then 2 plus 5, it is 7. 3 plus 6, it is 9. So we see that in the column called sum, we are having the sum of values in A and B. Then we are having the difference column, meaning that we are having 1 minus 4, it will be minus 3 or negative 3. 2 minus 5, it will be negative 3 again. 3 minus 6, it will be negative 3 again. So we are having a column called difference, in which we calculate the difference between the values in column A and column B. Then we are having a column called product. In the product, we see that there are numbers here as well. So we see 1 multiplied by 4, it's 4, the output here in the product column. 2 multiplied by 5, it's here and called in the product column, we have number 10, and 3 multiplied by 6, we see number 18 here in the product column. Then we are having the division column. For the division column, we see that the values in A and B, they are divided by each other. For example, here I change the formula. Instead of having AB, 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 I have B divided by A because the values are higher than this one. So for the division, I divide 4 by 1, it's 4. I divide 5 by 2, it's 2.5. I divide 6 by 3, it's 2. And finally, we are having the modulus column in which we find the remainder of the division. So 4 divided by 1, the remainder of the division is 0. We can calculate this. 5 divided by 2, the remainder of this division is 1. 6 divided by 3, the remainder of this division is 0. And we can calculate this. But how can I get to this data frame? So in order to get to this data frame, because we are adding new columns, first of all, we need to use the with columns function. So I use the with column function. So let me change the name of this one here, df2 and then df2. So I use the with columns function to add new columns to the df data frame. Df data frame is the data frame that we created originally. So this is the df data frame. So we use the with columns function to add a few more columns to the df data frame, which is this one. Okay. So what I would like to add are the sum columns, diff columns, product column, division column, and modula column. In order to add the title of the columns, we simply have dot alias. So dot alias, you see, I'm repeating it in different lines to add the name of the columns. Okay, so the name of the columns are there now. But how can I add the values to these columns? In order to add values, we are having inside parentheses, we are having the call of the function called col, or call, or it comes from the column. So the call function from the polars library is called for column that is labeled A, which is this one, and the value in that column must be added to the value in column B. Okay, so 1 plus 4, for example, 2 plus 5, 3 plus 6. I will say it one more time. So A column is called, and the value that is inside the column A is added to the value that is in column B using the call function col, let's say call function from the pandas library. And we'll label the column to be sum. This is how we are having the sum. So 1 plus 4, it's 5. 2 plus 5, it's 7. 3 plus 6, it's 9. Then I would like to have the difference column. So I name it using the alias function. I name it diff. Then whatever that is inside the column A is being minused from whatever that is inside in column B. And we label it to be diff. So this is the diff. So we see minus 1. 1 minus 3, it is negative 3. 1 minus 4, it's negative 3. 2 minus 5, it's negative 3 again. 3 minus 6, it's negative 3 again. So this is how we calculate it. Then I create a new column called product using the alias function. So whatever that is in column A is multiplied by whatever that is in column B. So we see the product, 1 multiplied by 4, it's 4. 2 multiplied by 5, it's 10. 3 multiplied by 6, it's 18. Then I would like to add a new column called division using the alias function. And whatever that is inside the column B is going to be divided by whatever that is in column A. So 4 divided by 1, it's 4. Here we see it. 5 multiplied by 2, it's 2.5. 6 multiplied by 3, it's 2. We see it here. And finally, we are creating the last column called modulo. And we use the alias function. And we see that whenever B is divided by A, the remainder of this division using the modulus operator can be calculated. And we fill the modulo column using this modulo. So we see that 4 divided by 1, the remainder of this division is 0. 5 divided by 2, the remainder of this division is 1. And 6 divided by 3, the remainder of this division is 0. Basically, this is how we can have basic arithmetic operations using the polars library for our data frame. Thank you for watching. Hello everyone, welcome to this video. In today's video, we're going to talk about scalar operations for our data frame in polars. So first of all, I import the polars library because we would like to work with polars data frame, so we need to also import its library. Then I would like to create my data frame in polars. In order to do that, I call the data frame function from the polars library. There I have only one column called x, and these are three values in my x column, 10, 20, and 30. And then all of this data frame is assigned to df, and we call it df. We call the data frame to be df, and then we print the df data frame. So this is how we can create our data frame. Then when I print the df, we see that here we are having 3 rows and 1 column. So the name of the column is x, as we chose here. Then in the first row, we see that number 10, in the second row, we see number 20, and in the third row, we see number 30 is shown here. So now I have a data frame with 3 rows and 1 column, and the name of my column is x. I would like to now perform some scalar operations, but how can I do that? And what are these scalar operations? Let me illustrate it with an example. So this is my data frame that I have at the end of the program, and we see that here we are having some new columns. So 3 columns are added, plus 5 times 2 divided by 10. And the first column is the same as the original data frame. So for the plus 5, we see that here we are having 15, 25, and 35. When we compare these values with the values that are in the column x, we see that 5 unit is added to each element. So it was 10, and now it's 15, 20, 25, 30, 35. So each value is added, is being added by 5 units. 5 units is being added to all the elements in the column x. So this is why we are having 10 instead of 10, 15, instead of 20, 25, instead of 30, 35. And also here we are having times 2. So whatever we are having in the original column, we are multiplying it by 2. So 10 multiplied by 2, it's 20. 20 multiplied by 2, it's 40. 30 multiplied by 2, it's 60. So we see here, and also in the last column we are having divided by 10. So 10 divided by 10, it's 1. 20 divided by 10, it's 2, and 30 is divided by 10, it's 3. So scalar operations means that we would like to perform some arithmetic operations with a static number. For example, in the first column, we are adding 5 units to all the elements, and the static number is 5. So we are having the value 5 being added to all the elements. Then we are having the number 2 as the static number. So everything that is here is multiplied by 2, and everything that is here in the last column is divided by 10. So my static number in the last column is 10. In this column it's 2, and in this column it's 5. Well, let me show you how we can do it. So because I would like to add some new columns, I need to call the with columns function for the df data frame. So df data frame is the data frame that we created here with 1 column only. This is the df data frame. So with columns function is called for the df data frame, and inside this function, first of all, we see that we are calling the alias function 3 times, meaning that we are adding 3 columns, and these are the titles. So in order to choose the title for the column, we need to call the alias function. So plus 5 times 2 divided by 10. So these are the titles of my newly generated columns. Then, for example, for the first new column, we call it +5, and what I do here is the following. So I use the values that are in the X column using the call function from the Pandas library, and I add a number that is static. So I add number 5 to all the values one by one in column X, and I add and I put the output, I add the output in the +5 column. So 10 plus 5, it's 15. Now I put 15 here. 20 plus 5, 25 is here. 30 plus 5, 35 is here. So whatever that is inside the column X, I'm going to add 5 unit to it and then put it in the +5 column, as you see here. Then for the next column, we are having ×2, and we call the alias function. And when alias function is used, it's called, let's say, we are having the title called ×2. And then we are using the call function from the Pandas library for the X column. So whatever that is inside the X column, whatever that is in the X column, let's say, is multiplied by a static number called static number. Okay, by a static number that is 2 in this case. So the scalar value here is 2. Okay, here everything that is inside the column X is multiplied by 2. So we see that 10 multiplied by 2, we are having in the times column, ×2. 20 multiplied by 2, it's 40. 30 multiplied by 2, it's 60. So we see that here we created the new column and we added the corresponding values. Then we are having the next column here called divided by 10 using the alias function. So whatever that is in the X column is divided by 10. Whenever it is divided by 10, we are having the output in the divided by 10 columns. So 10 divided by 10 is 1, 20 divided by 10 it's 2, 30 is divided by 10, so it's 3 in the output. And all of these operations that are performed on the df data frame, they are not being directly modifying the original data frame, but they are making a copy of it and doing the modification on the copied version. All of them are assigned now to df2, that we are creating a new data frame, and then we print the df2 and we see here in the output. So we see that here we are having 3 rows, the first row, second row, and the third row, and 4 columns. So first column, second column, third column, and the fourth column. So in this video, we learned how to perform scalar operations on our data frame in Pandas. Thank you for watching. Hello everyone, welcome to this video. In today's video, we're going to talk about logical operations, or let's say Boolean operations. So first of all, we need to import the Pandas library, and we would like to create a data frame and then perform logical operations. So in order to create a data frame, we call the data frame function from the Pandas library and we name it to be df. There we are having 2 columns, score and past. For the score, we are having 55, 80, and 90. For the past column, we are having false, true, true. So when I print the df here, we see that we are having 2 columns. First one is a score, second one is past. Then we are having in the score column, we are having 55, 80, and 90, exactly as we were having here. And then for the past, we are having false, true, true. So false, true, true. But how? Because we say, for example, we assume that someone who has the score of 55, this person is failed, and the other two people, and they passed the exam. So this is my data frame with 3 rows and 2 columns. So first row, second row, and the third row, and 2 columns, first column and second column. Then what we need to do is the following. I would like to get to this data frame, this one here, you see. So the first 2 columns are the same. The first 2 columns are the same, as you see, score and pass. They are as the same as the original data frame. Then we are having 4 new columns being generated here. For example, greater than 60, less or equal to 80, passed and above 60, and not passed. And for these columns, we are having Boolean expressions, so false or true. For example, in the column that we discussed, greater than 60, we would like to see if the score of the student X, for example, which is 55, is it greater than 60? No, therefore we are having false. These two, 80 and 90, they are greater than 60, so we are having true here. Less than 80. Is this number 55? Is it less than 80? Yes, true. Therefore, this is true. Less than or equal to 80. 80, is it less than or equal to 80? Yes, therefore we are having true. And 90, is it less than or equal to 80? It's false. So this is how this column is built. The same condition is here. So we are having the passed above 60. So the passed above 60, passed and above 60. For this, we are checking to see if the column is writing, if the column passed is writing down the above 60 number. Sorry, if the score column is having above 60 value and the passed column is actually having the true output. So here we see that we are having for the 55, we are having the false because it's not above 60 and therefore the person is not passed, and then we see that here it's false. But these two, 80 and 90, they are above 60 and therefore they are passed, so this is why we are having true here, and we see that here we are having the true in the output as well. And finally, in the last column, we would like to see who did not pass the exam. In order to find that, we see that here, if in the passed column, if the result is false, it means that that person did not pass the exam. Therefore, that person not passed the exam. So, for example, person number 1, this person, did this person pass the exam? No. This person, for example, let's say Alex. Alex did not pass the exam. So we ask the question, does Alex pass the exam? No. So the answer is no. Therefore, this is false. But when we reverse the question, Alex did not pass the exam. Is it true? Yes, it's true. So we are having true here. So for example, the second person is Reza. Reza passed the exam. Is it true? Yes. So the answer is yes. Therefore, we are having the true. But here we see that Reza did not pass the exam. Is it true? No, it's not true because Reza passed the exam. Therefore, the answer is false. So this third person, like let's say Sarah. Sarah passed the exam. Yes, so we are having true. But if the question was Sarah did not pass the exam, what is the answer? The answer is false. The answer is no. Sarah passed the exam. So this is how we're filling this part as well. But how can we reach to this data frame? In order to reach this data frame, we need to use the with columns function. With columns function is called for the df data frame, which is our original data frame that we created here, and all of them are assigned to a new data frame called df2. And the with columns function is going to work with a copy of the df data frame and not directly modify the original data frame. Okay, so here we use the with columns because we want to add new columns. So we see that here alias function is called 4 times, meaning that we are adding 4 new columns. So the title of the first column is greater than 60, and we check a condition in the score column. Is the numbers, are the numbers larger than 60 or not? If they are larger than 60, return true, otherwise return false. So if this condition is true, we're going to have true. If this condition is not true, we're going to have false in the output. So we check the values in the score column using the call function from the Pandas library, and we go through it one by one. For example, we check 55. Is it larger than 60? No, we're having false here. 80. Is it larger than 60? Yes, so we're having true here, greater than, in the greater than 60 column. 90. Is it greater than 60? Yes, it's true. So we see that we're having true and false here. Next condition. Next column is called less than equal, less than or equal to 80. So we see that. So for the next column, that is less than or equal to 80, we are having the column title here, less equal 80. This is the title using the alias function. Then we have this condition. So the condition is we go through the values in the score column using the call function from the Pandas library, and we check if the value, if let's say values are lower than or equal to 80. If so, put true. If not true, put false. So 55, is it less than or equal to 80? Yes, so we're having true. 80, is it less than or equal to 80? Yes, so it's true. And we are having 90. Is it less than or equal to 80? No, it's not true. Therefore, we are having the false here in the output. Then for the next column, we have the title using the alias function past and above 60. And the condition is this one. So we are checking to see for the past column, to see in the past column if it's true or not. So in the past column, this is the past column. So if it's true or not, then we also check to see if the values in the score column, they are larger than 60. So because we are having an AND operator, both conditions must be true. This one and also this one. So if it is written past in the past column and also the score of that corresponding row is above 60, we're going to have true here, otherwise we're going to have false. So let me illustrate it with an example. Here we see that number 55 and false. So we check 55, is it larger than 60? No. And do we have a true here in the past column? No. Therefore, the answer is false. So here we are having number 80 in the score column. So 80, is it larger than 60? Yes, it's true. And do we have a past written or do we have a true written in the past column corresponding to this row? Yes, so the answer is true. Okay. Finally, we are having the 90 and true. So 90, is it larger than 60? Yes. So we pass this condition. And what about this condition? Do we have a true in the past column? Yes, we are having true. Therefore, the answer is true here as well. Then we move on to the final column where we label it not passed using the alias function. And for this part, we check for the passed column. So we check the passed column and we are having a tilde sign here. So whatever that is in this column, we are going to reverse it, okay, in the not passed column. So for example, if it's false, we want to have true. If it's true, it's false. If it's true, it's false. So using the tilde sign, whatever that is in the past column is reversed. So if it's false, now it's true. If it's true, now it's false. And we explained why do we have such a logic for not passed and passed as well. So in this video, we learned how to deal with logical operations, or let's say Boolean operations. Thank you for watching. Hello everyone, welcome to this video. In today's video, we are going to learn how to combine conditions with filters in polars when we are dealing with data frames. So first of all, we need to create our data frame. In order to create my data frame, I call the data frame function from the polars library, and I call my data frame to be df. In this data frame, I'm having these information. First of all, we're talking about age, which is my first key. And second of all, we're talking about status, which is my second key, because we are creating our data frame from a dictionary. And in dictionaries, we know that we are having key value pairs. So when creating a data frame from a dictionary, we know that dictionaries, they have key value pairs. So we are going to have key value pairs. And here we see that, for example, the first key is age. So we are having 4 associated values to this age: 25, 17, 35, and 16. Then we are having the key status, and we are having 4 value pairs associated to the status key. So we are having adult, minor, adult, and minor, meaning that the first person, for example, is 25 years old, and this person is labeled to be an adult. Then the second person is 17 years old, and this person is labeled to be minor, for example. The third person is 35 years old. This person is labeled to be adult. And the last person is 16 years old, and this person is also labeled minor. Now that I created my data frame, I would like to print it first of all. So print df. So we see it here in the output when I run the code. First of all, we see that we are having 4 rows and 2 columns. So this is the first row, second row, third row, and the fourth row. Then we are having 2 columns, age and status, as you see here, age and status. So 2 keys, age and status, has become our 2 columns, age and status here, and our values are our rows. So the first row is one observation. For example, the person with 25 years old, this person is labeled to be adult. So this is my original data frame. Now I would like to have a different data frame from this data frame, and there should be some conditions. This is my second data frame. So you see that there are 2 rows and 2 columns. So columns are the same, age and status. But in the rows, we see only people who are adult. You see the status of both of the rows is adult. So minor people are excluded. So it means that we filtered based on some criteria to keep only the adult people. Now, in order to filter, here we would like to filter adults above 18. So the people who are above 18 are labeled adult. And in the second data frame, I would like to keep only the adults. Therefore, I use the filter
function for the df data frame and I define my conditions. This is my first condition. The first condition says that go through the column age using the call function from the Polars library, and the values that are larger than or equal to 18, this is the first condition. So the age should be, let's say must be, larger than or equal to 18. This is the first condition. And so we're having an AND operator. This is the second condition. In the status column, go through whatever that is written in the status column using the call function from the Polars library and check to see if the status equals adult. So this is the second condition. So the first condition, the person is older than or equal to 18 years old. The second condition is to check if the status of the person equals adult. If so, only keep these rows that can pass these two conditions. And because we're having an AND operator, we must meet both conditions, not one of them, both of the conditions. And this is basically the output of this filtering is assigned to a data frame called filtered, and we are printing filtered in the output. So let's do it one by one ourselves. So here in the first row, here we check if the 25 is larger than 18. Is it true? Yes, it's true. So, okay, let's go for the second condition. The status of the same person, is it adult? Yes. Therefore, this is what we are looking for. This row is a valid row. So this row is added to the filtered. So we see that we are having 25 with adult, okay, with the status of adult. Then the second row, 17 years old, is it larger than or equal to 18? No. So the first condition is not passed, therefore we cannot have the second row. Why? Because when we are having AND operator, both conditions must be true, and here we are not having the first condition to be true, therefore we cannot have this row. But we're going to further check this row, and we check if the status in the status column equals adult. It's also not true because it's minor, therefore we are not going to have this person, this row, in the filtered data frame. So you don't see this information here. We don't have anyone with 17 years old who is labeled as minor. Then we are having the third row. So 35, is it larger than or equal to 18? Yes, the first condition is true. How about the second condition? This person is labeled adult. Yes, it is labeled adult. So we want this person, and we are having this person 35 years old and label adult. And finally, we are going to have the last row. And here we see that the person is 16. Is it larger than 18? No. Is this person labeled adult? No. So this person is not inserted here, because we're having an AND operator. If we were having an OR operator, if this condition was true or this condition was true, it would have been okay, and we could insert the info in the second data frame. But because we are having AND operator, both of them must be true. So here in this video, we learned first of all how to create our data frame. Then we learned how to have conditions. Here you see this is the first condition, this is the second condition, being combined with the filter function. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to use when, then, otherwise for conditional logic for a data frame in Polars. First of all, we're going to import the Polars library because we need to create our data frame in Polars. Then we are having the creation of the data frame. In order to create our data frame, we are calling the data frame function from the Polars library. And here we are having one column with 3 values in the data frame. So the column name is score. Then there are 3 values there, like 45, 67, and 88. So these are the three values there. And these are assigned to the data frame called df. So the name of this data frame that we just created with one column called score with three values is df. So first of all, I print df so we can see the data frame. We see that here we are having 3 rows and 1 column. So the column is labeled score as we dedicated here, as we want it here. And there are 3 rows, the first row, the second row, and the third row. So these are the scores of 3 students. So the first score is 45, the second score is 67, and the third score is 88. Now I would like to add a new column and create, first of all, I need to create a new data frame from the original, from the current data frame. And the new data frame that I created here, I would like to have a new column called result. And based on the score that we are having in this column, I would like to have some status here. For example, the person who is having the score of 45, this person is failed. The person with the score of 67 or 88, these 2 people are passed. But how can I have this result column based on the scores? In order to have that, first of all, we use the with columns function. Whenever we would like to add a column to an already existing data frame, we use the with columns. But with columns is not going to directly modify the original data frame, but create a copy of it and modify the copied version, and that copied version is then assigned to df2. So we are calling the with columns function for the df data frame that we just created here, and we saw the output here, within which we are first of all labeling the column. So the label of the column is a result, and we label it using the alias function. Now we would like to have some conditions. We call the when function from the polars library, and we say, okay, go ahead and check the values in the score column using the call function from the polars library, and if scores are larger than or equal to 60, then label them as pass using the literal function from the polars library. So the first part here, it is going to evaluate this 45. Is it larger than 60? No. So it's not going to label it as pass in the new column that we called result using the alias function. So if this condition is not passed, otherwise, go to the otherwise. You're not going to implement this part because this condition is not passed. You're going to go to the otherwise part, and you're going to write down fail using the literal function from the polars library in the result column. So 45, is it larger than 60? No. Then go to otherwise and write fail in that row for the result column. So we see that fail is written here. Then we go for the second row, 67. This is my score. Is it larger than 60? Yes. Now that this condition is true, write down pass status using the literal function from the polars library. So we see pass is written here. And whenever this first condition is true, then this then function is activated. Okay, if this condition is not true, it is going to jump to the otherwise. Okay, and finally the last row, 88, we check to see if 88 is larger than or equal to 60. Yes, it's true. Now that it's true, then write pass using the lit function from the polars library in the result column, and you see that here we are having the pass here in the output. So in this video we learned first of all how to create a data frame with multiple rows and one column only, and then how to use the when, then, and otherwise functions along with columns function to add a new column called result and assess the already existing column score based on certain conditions and write down the status of the corresponding rows in the column result. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to have some mathematical operations and logical operations being combined in one example. So first of all, we're going to have the import of polars as PL because I would like to create my data frame using the polars library. So I'm going to first of all import the polars library. Then I would like to create my data frame that is called df. So I have a data frame function being called to create the df data frame from the polars library. Here I'm having the creation of my data frame from a dictionary. And in dictionaries, we know that we are having key and value pairs. Key and value pairs. So we are having two keys, X and Y, and we are having three corresponding values for each key. So for the X key, we are having the 10, 20, and 30 as values. For the key Y, we are having 1, 2, 3 as values. So now I created my data frame called df, and I am printing the df data frame. So when I run the code, I see the data frame here in the output. First of all, we see some information about our data frame. So we are having the data frame with 3 rows and 2 columns. So 3 rows and 2 columns. And when we want to verify these numbers, we see that yes, we are having 2 rows, X and Y, and we are having we are having 2 columns, X and Y, and we are having 3 rows. This is the first row, the second row, and the third row. Now that I printed my data frame, I would like to create a new data frame and perform some specific arithmetic and logical operations. For example, here is my output. This is the second data frame that was created from the first data frame. So we see that here we are having 2 newly generated columns. So we are having complex arithmetic and we are having complex condition. And here for the complex arithmetic, we see certain numbers. And for the complex condition, we see the status true is there for all 3 rows. But how can I do this, and how can I write this down and add 2 new columns and do some calculation? In order to do that, we use the with columns function for the df data frame that we just created. And we name the new data frame to be df2, and finally we print the df2. So now that I use the with columns function, I would like to have 2 new columns. So I use the alias function to label them. The first one is labeled complex arithmetic. The second one is labeled complex condition. Okay. Now that I have these 2 columns, I need to fill them with some values. For the first column, let's say. For the first column that is called complex arithmetic, I am having some arithmetic operations. And this is, we are telling the compiler saying that, okay, go and check the column X using the call function from the polars library. So go and check the value that is in the column X for each row one by one and add that number from column X to the number that is there in column Y, and the output of this addition must be multiplied by 2. What does it mean? So if I want to explain it further, we see that in the first row, for example, the value in the column X is 10. So we are basically having 10 plus the value in the
column y for the first row. So this is what we have here, 10 plus 1. So 10 is being read from the column x, 1 is being read from column y. Then the output of this is multiplied by 2. So the output would be 10 plus 1, it's 11, multiplied by 2, it is 22. So we see that 22 is written here. So this column, complex arithmetic, is calculated based on the values in each row in the x and y columns. Okay, now let's go to the second column. For the second column, we are having the value of x to be 20, which is here, plus number 2. So 20 plus number 2, then multiplied by 2 based on our formula here. So we are having 20 plus 2, it's 22, multiplied by 2, it will be 44. So we see that 44 is written here. Okay. Then we are having the value in the last row, and for the x column, it's 30. It's 30 plus 3. 3 is the value in the y column. This is multiplied by 2, and we are having the output of 66, because 30 plus 3, it's 33. Multiplied by 2, it is 66. So we see that 66 is in the output. Okay, so this is how the first newly generated column is filled from the values from the first two columns with performing some arithmetic operations. Now we would like to fill the complex condition. So again, using the alias function, I label the column to be complex condition. Then we need to have certain conditions to see if we need to write true or false for each row in this column. So first of all, we're going to start with the first column. The first column, here it says that check the value in the x in each row if it's larger than 15, or if this condition is not true, check to see if y equals 1. If either this condition or this condition is true, we are going to have true in the output. If none of the condition is true, we are going to have false in the output. So in the first part, in the first row, x value is 10. So 10, is it larger than 15? No, this condition is not true. Because we are having OR operator, we are going to check the second condition as well. So y, the value in the y column, is it equal to 1? Yes, so this condition is true. Therefore, we are going to have true in the output. Then for the second row, we check to see 20, is it larger than 15? Yes, this is true. So because we are having OR operator and we checked one condition and at least one condition is true, so we are going to have true in the output, and we don't care about the second condition at all if the first one is true. But for the sake of just our knowledge, we're going to check this second condition as well. So the value in the second row for y, is it equal to 1? No, it's 2. So this one is also false. The first one was true, so we are having true in the output. Then for the last row, we are having the value of x, which is a 30. So 30, is it larger than 15? Yes, this is true. So we are going to quickly guess that we are going to have true in the output of the third row for the complex condition column. And for the second condition, we check and see that, okay, y, is it equal to 1? No, it's 3. So this condition is false, but we don't care because we are having an OR operator. So here in this video, we learned how we can have arithmetic operations and logical operations being combined in one example. Thank you for watching. Hello everyone, welcome to this video. In today's video, we would like to have the null-aware operations for our data frame in Polars. So first of all, we're going to import Polars library as PL because we would like to create our data frame using the Polars library. And then in order to create our data frame, we call the data frame function from the Polars library and we name it to be df. Then we are having the information in our data frame. So the data frame is created based on a dictionary, and here we see that we are having the key A, and these are the corresponding values. We are having the key B, and these are the corresponding values. So we are having two keys and their corresponding values. And we know that in dictionaries, we are having key value pairs. So in the first part where we are having the key A, we see that the values are 1, none, and 3. So we are having one missing value there. And then we are having the second key, which has the values that are 4, 5, and none. And we are also having one missing values there. But how can we deal with these values and how can we perform some operations over these values? We're going to learn in this video. So first of all, we're going to print the df data frame, the data frame that we just created here. So this is the df data frame. We see that here we are having 3 rows and 2 columns. To verify that, we are having 2 columns called A and B, and we are having 3 rows. This is the first row, this is the second row, and this is the third row that we are having here. Now, I would like to create a new data frame from the original data frame, and I would like to add 2 new columns called sum and product no null. Okay, no null. So the first 2 columns are the same as the original data frame, but here in the sum column we see that, for example, 1 plus 4 it's 5. Then we are having the null plus 5. The output is null because we don't know anything about the value of this. Then we are having the 3 plus null, which is again null. And then we are having here the production of the A and B. So 1 multiplied by 4, it's 4. Null multiplied by 5, it's 0. 3 multiplied by null, it's 3. But how is that even possible? We're going to understand it now. So first of all, because we would like to add new columns, we call the with columns function. And we are using the alias function. Alias function is used to label the 2 generated columns. How do I know that I have 2 columns? Because I wanted to create 2 columns. So I have, this is my first column and this is my second column. And then using the alias, I'm going to title them. So sum is the label of the first new column. Then product no null is the label of the second new column, okay, or let's say the 4th column. Now I would like to fill the sum column. How can I do that? I simply say to the compiler, go and check the values row by row that are in the column A, and then we call the column. So now I would like to fill the values in the sum column. So I have the alias function to label it to be sum. Then in order to fill this column, I have this formula being written there. So I tell the compiler to go for the values that are in the A column row by row and add them to the corresponding counterpart of the column B. So for example, here 1 plus 4, so the first row it's 5. So 5 is written in the sum column. Then because this is a missing value and it is added to 5, we are having the null. And then because we are having 3 plus a missing value, it will be null again. So this is how the sum column is filled. Then we would like to fill the product no null. So first of all, I use the alias function to call this column product no null. Then I would like to fill the values, but because we are having missing values here, we would like to have the change in the missing values and insert some values there, and then to see how we can fill the product no null column. So here I use the fill null function to say that, okay, if you're going through the A column using the call function from the Polars library and you see any null or missing values, fill it with number 0 and multiply it by the values that are in column B. But if you see any missing value, so we have the fill null function in the B column B, fill it with number 1. So now previously we saw that we were having the column A and column B. In the column A first row we were having 1, for the column B we were having 4. So null was here, and here it was 5, then here it was 3, and here we were having the null. Okay, so here we see that these are the values for the already data frame, but I would like to change the null values, or let's say the missing values. I say whatever you see in the column A that is a missing value, fill it with 0. So now null is removed and 0 is there. Okay, and whatever you see as a null value, or let's say missing value in the column B, replace it with 1. So this one is now number 1. So we changed the values in 2 columns. And now that we did this revision, this modification, do the multiplication. So 1 multiplied by 4, it's 4. 0 multiplied by 5, it's 0. And 3 multiplied by 1, it's 3. So this is just an assumption that we want to replace the missing values in the column B with value 1 and their counterpart in column A with value 0. You can change it as you wish. You can insert, for example, number 10 instead of missing value. This was just an example to show you how we can fill actually the null values. And we see that here we performed some arithmetic operations, and we also dealt with the missing values, and then we carried on with the arithmetic operations. Thank you for watching. Hello everyone, welcome to this video. In today's video, we're going to learn about a rename function. So first of all, we're going to create our data frame in Polars. So we're importing the Polars library, and then I call the data frame function from the Polars library to create my data frame called df. And in my data frame, I have 2 columns. So the first column is first name, the second column is last name. In the first column, I have these 2 names, Alice and Bob, and for the last name, I have these 2 names, Smith and Johns. So when I print the df data frame, you see here I have 2 rows and 2 columns. 2 columns, the first column is first name. This is the first column. Second column is the last name. Then we are having the first row and second row. So Alice Smith and Bob Jones. So this is the data frame that I just created. And now I would like to rename the columns. In order to rename, we can simply use the rename function for the df data frame that we just created here. The new data frame is called df2, and then here we are having the first name, last name. So these are the current names of my columns, and I would like to modify them. So I write down first, then after colon I have the new name that I would like to have for them. For example, first underscore name and last underscore name. So when I run the code, I see that first column name is first name and then the second column is last name. However, it was first underscore name and last underscore name. So we see that here we are having a different column name. Basically, we use the rename function for the df data frame in order to rename the column's name. Thank you for watching. Hello everyone, welcome to this video. In today's video, we are going to learn how to drop a column or how to eliminate a column. First of all, we are importing the polars library because we would like to work with data frames in polars. Then I create my data frame. So a data frame function is called from the polars library and the name of my data frame is df. Here I'm having three main keys: ID, name, and age. And for each one of them, we are having the corresponding information. For example, for the ID, we are having two IDs, 1 and 2. For the name, we are having two names, Alice and Bob. And for the age, we are having two values, 25 and 30. So then I print the data frame df so we can see it here in the output. We see that we are having two rows and three columns. So three columns like ID, the first column, second column is name, and the third column is age. Then the first row is this one and the second row is this one. Now I would like to drop the age column. So I don't want to have it anymore. And you see that this is my second data frame in which I have the ID, in which I have the name, but I don't have the age column anymore. In order to drop a column, we can call the drop function for the df data frame. And then in parentheses, we write down the name of the column that we would like to drop. And all of this is assigned to df2, a new data frame, and we are printing the data frame. And we see that here the age column is not there anymore. Another thing that we can do is to change the name of the column that we are dropping. So we don't want to drop age anymore. I would like to drop the name column. So in the final data frame, I'm going to have the ID and the age. So we see that ID and the age, we are having both of them, but the name is not there because I dropped the name column here. So in this video, we learned how to drop a column in data frame in polars. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn about how to drop columns with select function. So here is my data frame. I create the data frame. So I call the data frame function from the polars library. I name it to be df. I have three keys and their corresponding values. For example, for the key A, I have the values 1 and 2. Then for B, I'm having the 3 and 4. And for C, we're having 5 and 6. And finally, I'm printing the data frame df. So we see that here for the df data frame, we're having three columns, A, B, and C. And we are having two rows. So here it says two rows also and three columns. Three columns, A, B, C, and two rows. Now I would like to only have the column A and C, and I don't want to have the column B. One way that we learned about this is to use the drop function. So if I use the drop function, we learned how to drop the column B. So we're going to have the column A and C. But here we would like to use the select function, which is going to help us to select, for example, columns A and C. And because we would like to select these two and we're not selecting B, we are going to have A and C in the output. Okay, so this is the original data frame. This is the output. This is the second data frame that we created from the first data frame. So we see that here, instead of dropping B, we are only keeping A and C. We are going to have the same result, but the method is different. So this is the data frame that we created, and here is the original data frame, 2 rows, 3 columns. Now we would like to keep only a subset, let's say, of the columns. It's an alternative to drop function. In order to do that, I call the select function for the df data frame, and inside the parentheses and square brackets, I'm saying that I would like to select columns A and C. So I would like to keep them. And when I keep A and C, it means that I don't want B anymore. Okay. And this is assigned to a new data frame called df2, and we print the df2, and we see here we are having A and C. So instead of A and C, if I was having A and B, it means that I would like to keep A and B, and I don't want C anymore. So A and B I would like to keep, and we see A and B, both of them are there. So in this video we learned an alternative to drop function, and that is the select function. So we can keep only a subset of the original data frames column. Thank you for watching. Hello everyone, welcome back. In today's video we're going to learn how to rename the columns while we are using the select function. So first of all, you see that this is my first data frame. I have 2 columns, so sales and cost. And this is the second data frame that I created from the first data frame. And instead of having sales, I'm having the revenue. Instead of having cost, I'm having expenses. And I added a new column called profit. But how can I do that? First of all, I import the polars library, then I create my data frame. In order to create my data frame, I call the data frame function from the polars library. The name of my data frame is df, and in my data frame I'm having sales column and cost sales and cost. The information for the sales are 100 and 150, so we see that this is here, and also 70 and 90 are the info for the cost. So this is the first key with its corresponding values 100 and 150, and this is the second key called cost these are the corresponding values 70 and 90. So I created my data frame here, so and I'm printing the data frame, so we see it here in the output. Now I would like to create the second data frame called df2, and I call the select function for the df data frame, the first data frame, in which I would say, okay, I would like to have all the values in the sales column from the first data frame using the call function from the polars library, and I would like to use the alias function to title the column instead of sales to call it revenue. Okay, so I use the alias function because I'm using the select function, and select function is going to select certain columns of the original data frame. Okay, so and then alias function is going to help me to rename the column, because first of all I call the information, it's like I'm getting all the information, all the values like 100 and 150 from the sales column from the df data frame using the select function, and I'm assigning it to df2. So these values that are taken from the sales column of the data frame df are being labeled to be revenue here. Okay, the same happens with expenses. So I label the second column of the second data frame to be expenses instead of having the cost name. Okay, so I'm taking all the values in the cost data frame, in fact, using the the cost column. I'm getting all the values from the cost columns using the cost call function from the polars library, and I'm going to use the alias to call it expenses. Okay, so I'm having the expenses. And finally, I create a new column called profit using the alias function, and we are having its value being calculated as sales minus cost from the df data frame. And we see here 30 and 60 is there. So 100 minus 70, it's 30. 150 minus 90, it's 60. So we see it here in the output. One important thing to remember is that previously we learned about adding new columns using the alias function, but there we were calling the with columns function and not the select function. Now I'm calling the select function within which I call the alias function. Okay, so when I use the select function, it means that I'm selecting an already existing column, but I would like to rename it. With column function was supposed to help me to add new columns. Okay, so this is the difference. For as a reminder, you can go back to videos and watch the videos that are related to a with columns function. So in this video, we learned how to create the second data frame based on the first data frame, in which I rename the columns, and also I create a new column as well. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to use the group by function and how to aggregate values. So first of all, let me show you the output. This is my original data frame. It has 5 rows and 2 columns. Columns are group and value. And we see here, for example, the first row is for A, the second row is for A, the third and fourth rows are for B, and finally we are having the row C. And we see that here we are having the second data frame created based on the first data frame. So first data frame. So in the second data frame, we are grouping by the A, B, and C. So we do not have the repetition A, B, B, and C. We are having A, B, and C. And in the second column, instead of value, we are having the sum of values. So we are having A equals 30. 10 plus 20, the values for A in the first data frame, now they are 30. B, it's 70 because we were having 130 and 140, so it's now 70. And C is 50, and we see that here C is 50. So we are grouping the groups, let's say, and also we are having the aggregation of the data. For example, we are having the sum of values of each group. In order to do that, first of all, I need to create my data frame. Here, I'm creating my data frame called df1. You see here. So in order to create the data frame, I call the data frame function from the Polars library. Here, I'm creating my data frame from a dictionary. So in dictionaries, we are having key and value pairs. Here, I have 2 keys, group and value, and these are the corresponding values for these 2 keys, A, B, B, and C, 10, 20, 30, 40, and 50. So for example, for group A, the value is 10. For the group A, again, the value for the second, let's say, group A, the value is 20. Then we're having B 30, B 40, and C 50. So first of all, I'm going to print this data frame so we can see it in the output. As we saw here, this is the first data frame with 5 rows and 2 columns. Also, I draw this data frame here as well, so it's a good reference for us to look at it when we're performing other things. So here, as you see, we're having the original data frame being printed. Then we need to group the data frame by the group column. Okay, we need to group the data frame by the group column and aggregate the value column. Okay. In order to do that, we simply call the group by function for the group column in the df data frame, because we would like to group the data frame based on the group column. Okay. And instead of group, we could have category, for example. So if I change this to category, so here I would say when I run the code, so we see here it's category. So here also it's category. So it is going to little bit make problem with my table here, but it's okay. So now I would like to have the first group, the first column is category, it's not group anymore. The second column is value, so category and value. So we would like to group the data frame based on the category column and aggregate the value column. Okay, so I call the group by function for the category column of the df data frame, and we are going to aggregate. What is that we are going to aggregate? We are going to aggregate the sum of value, the sum of the values that are in the value column using the call function from the Polars library, and we are going to label it as the sum value using the alias function. Okay, so if I want to repeat one more time, is we are aggregating the value column. The aim is to aggregate the value column, because I would like to have the A to be 30, which is the sum of 10 and 20. Okay, so we are aggregating based on the value column. So now in order to do that, I call the aggregate function, and I mention, okay, calculate the sum of the values inside the value column using the call function from the Polars library, and this is the sum function that is going to help us to calculate their sum. And using the alias function, I'm labeling the column to be sum values. So we see that here it's sum values, it's not value anymore. Category, sum value. Okay, so all of this is assigned to the result data frame. And finally here I'm printing the result data frame. So we see that here in the result data frame we are having the category. Let me also category. We are having the category column and the sum value column. So category A, B, and C, and the sum of the category A is 30, which comes from the 10 plus 20. For the B, it's 30 plus 40, which is 70. For the C, it's 50, and it's the only row that we are having for category C. So in this video, we learned how to create our Polars data frame first of all. Then we learned how to use the group by function to group the data frame based on the category column, and also to aggregate the value columns. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about multiple aggregation. So first of all, we would like to create a Polar data frame, and then we would like to have multiple aggregation based on one column. So here, first of all, we create the Polar data frame, Polars data frames. In order to do that, I call the data frame function from Polars library, and I call the data frame to be df. And I create my data frame from a dictionary, and dictionary itself is a key value pairs. So keys are category and value, and the values are A, B, B, C for the category key, and the values for the value key are 10, 20, 30, 40, and 50. For example, the category A is 1 times 10. The category A, again, it's 20. B is 30. B is 40. And C is 50. So this is my df data frame. First of all, I would like to print it. So when I print the df data frame, we see it here in the output. So it's a data frame of 5 rows and 2 columns. So we are having 2 columns, category and value. Then we are having 5 rows. This is the first row, second row, third row, fourth row, and the fifth row. So we are having the first row, which is A10, second row A20, third row and fourth row is they are about the category B with the values 30 and 40. Then we are having the category C, which is 50. Now I would like to group by the category column and have multiple aggregations. So let's see the output first, and then we discuss how we can reach to this output. So as you see here, I am having the category B, C, and A. So we're grouping by the category. We don't have the repetitions. We don't have A, B, B, C. We're having one B, one C, and one A. Why? Because we're grouping by categories. And we're going to aggregate the data, for example, for category A, category C, and category B. Now I would like to aggregate, first of all, the sum of values. In order to have the aggregation over that, we are having the category B equals 70. But how can we reach 70 actually? We are having 30 and 40. So 30 plus 40, it is 70, which is the sum of the all values in the category B that we are having in the sum column. Then for category C, we are having one category C, so 50 is there, so 50 is there. For category A, we are having two rows, 10 and 20, so their sum will be 10 plus 20, it will be 30 that we are having here. So this is the first aggregate. This is the first aggregation that we're having in the second column here that you see. Then we are having the mean of the values. So now I would like to calculate the mean of the values that are associated with category B. So 30 plus 40 is 70, divided by 2, it's 35. So the average of the values in the category B is 35. The same goes with the category C, because we only have one row for category C. We are having the mean is equal to the only number, and also the sum is also equal to the only number. Then for category A, we are having again two rows here, as you see. And when we have two rows, in order to calculate its mean, we are going to have 10 plus 20, it's 30 divided by 2, it's 15. So this is the third column that we learned how it is calculated. And finally, we are having the fourth column, which is called count value. For the count value, as you see here, it is going to count the number of values associated to each category. For example, for category A, we are having two values, 10 and 20. So number 2 is there. For category B, we are having 30 and 40. So number 2 is there. And for category C, we are having number 1 is 1, because we only have one value associated to this category. But this is the explanation of what has happened as in the output. But how can we reach to this table that we can have such a valuable information regarding different categories? So first of all, we would like to group based on the category column. Okay. So we would like to group the information by the category column. So we don't want to have A, B, B, and C. We want to have A, B, and C. So we are aggregating the data. So we would like to first group by the category, okay, and then aggregate the data associated to these categories. First of all, we are going to label the columns that we would like to have. So alias function is going to help us to label the columns. We are having 3 times of the alias call. So we're having sum value, mean value, and count value. So this is the first column, second column, let's say second column, third column, and the fourth column. So sum value, mean value, and count value. Using the alias function, we are labeling them. Then we would like to aggregate the data associated to each category that are stored in the value column. Okay, so the values that are associated to categories are in the value column. So we are going to have the sum of the values in the value column using the call function from the polars library for each category. Okay, so sum of the, for example, category A, sum of the category A is calculated. That are the numbers in the value column. So 10 plus 20, it's 30 there. The same goes for B. So 30 plus 40, it's 70. And for C, we are having 50 here. Okay. So using the sum function, we are calculating the sum of the values associated to each category in the value column using the call function from the polars library and the sum function. So this is basically how the second column is filled. Now, with respect to the mean of the values, we're going to do the same thing, but instead of the sum function, we are calling the mean function, which is going to calculate the average of the values in each category. Okay, so for category A, for example, we are having two values that are shown in the value column. So we call the mean function for the values that are in the value column using the call function from the Pandas library for each category, because we are grouping by each category. So using the mean function, we are having the A to be 15, B to be 35, and C to be 50. These are the values for the mean here. And finally, for the count value in this column, we see that we are having the number of values associated to each category. So we are having two values associated to A, two values associated to category B, and one value associated to category C. How can we do that? Thanks to the count function, we can do it simply. We can count the values associated to each category that can be traced in the value column using the call function from the Pandas library. So basically, this is how we can have such a great table, or let's say data frame in the output, that we can have the group by based on the category and aggregate multiple. We could have multiple aggregations. For example, here we're having the sum, mean, and the count value. Thank you for watching. Hello everyone, welcome to this video. In today's video, we are going to learn how to group by multiple columns in our data frame. So first of all, we would like to have a polars data frame. Therefore, we need to import polars library first of all. So very important, polars library as PL. Then I need to create the data frame. In order to create the data frame, what we need to do is the following. First of all, we are going to call the data frame function from the polars library. And we name this data frame to be df. And finally here in the end, we are first of all printing the data frame before doing any grouping by multiple columns. Now, in order to create my data frame, I am using a dictionary. So it's a dictionary that has three keys: category, subcat, and value, and their corresponding values. So these are the values for the category key. These are the values for the subcat key, and these are the values for the value key. So because we are having a dictionary, we need to remember that we were having key value pairs, and here the keys are category, and its values are x, 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 y, y, and we are having another key called subcat. The value that is associated to this key are a, a, b, a, a, and finally the values are for the value key are 10, 20, 30, 40, and 50. So for example, we can have the category X with the subcategory A. The corresponding value is 10. Then we are having category X for the subcategory A again, but this time the value is 20. For example, this is the data of the same category and subcategory, but for another month, for example. This could make sense. So we create our data frame, and then we are printing the df data frame. So here we see that we can have the printed version of our created data frame. So the data frame is called df. It has 5 rows and 3 columns. So the columns are category, subcategory, and value. So these are the 3 categories, and each row is an observation. For example, we are having the category X and subcategory A, its associated value is 10. We are having X, A, and 20. We are having X, B, and 30. We are having Y, A, and 40, and Y, A, and 50. Now I would like to group based on the categories, but based on 2 columns. So this is why we say that we are grouping by multiple columns, because we would like to group by 2 columns. First column that we would like to group by is category and then the subcategory. So we would have something like this in the output. We not only have the category being grouped by, so X, X, and Y, but also we are having the subcat, which are the A, B, and A. So what's happening here is the following. So we are having X here. So we see that X is in 3 rows for subcategory A and B. Then we are having Y, category Y, for only the subcategory A. So when we are grouping by category, we are going to have X for A, X for A, X for B, and Y for A. Okay, so this is basically how I am having the group by category and subcategory. For example, let me remove this part. So if I remove this part and I run the code one more time, you see that here I'm having X and Y. That's it. So because I am only grouping by categories and not subcategories, and in categories we are having only X's and Y's. So we're grouping by all the X, so we see X one time, and the Y's. So, and we're having the Y's. And we're calculating their sum as well, that we're going to discuss in a few seconds. But when I have the category grouped by 2 categories, we see that we are having X and the subcategory. So X for A, X for B, and Y for A. So this is the first thing that we need to learn. So we're grouping by 2 categories. Then we are having the aggregation of data. We are having the sum of values. For example, for X, for category X and subcategory A, we are having 2 associated values, 10 and 20. We would like to have their sum. So 10 plus 20, it's 30 that we are having here. For category X, subcategory B, we are having only 1 associated value, so it's 30. For category Y and subcategory A, we are having 2 associated values, 40 and 50, so their sum will be 90. But how I'm doing this here? So now what we want to do is that we saw the data frame in the output. Now we would like to see how we can reach to such a data frame, such an aggregation of data and the grouping by based on the different columns. So this was the original data frame that we saw the output here. Now I would like to have this output based on the first data frame. What I need to do is to call the group by function for the df data frame. So df is the name of my data frame. And I would like to group by multiple columns. I would like to group by based on the column called category and based on the column called subcat. So these are the columns based on which I would like to have the group by. Then also I would like to have the aggregation of my data. So I call the aggregate function for all the values that are in the value column. Using the call function from the Pandas library, we calculate the sum and we label it to be sum value using the alias function. So this is how we can reach to such an output. So in this video, we learned how to create our data frame, how to group the data frame based on 2 columns, and how to aggregate data based on the values associated to those 2 columns and calculate its sum, and how to also label the column. Thank you for watching. Hello everyone, welcome to this video. In today's video, we are going to learn how to aggregate multiple values at once, or let's say how to aggregate multiple columns at once. So here is my original data frame. First of all, I'm going to show you how the output looks like, and then we're going to learn how to reach this output. So this is the original data frame. We are having the group A, B, and C, and associated value to these groups are shown in val1 column and val2 column, and they are independent. Val1 and val2, they are independent. I would like to group based on this group column, and I would like to aggregate the sum of these values, val1, and the average of the val2. Okay, so in order to reach that, first of all, I need to import my polars library because I am creating a polars data frame. So in order to create a polars data frame, I call the data frame function from the polars library. I call my data frame to be df. Then I would like to create it based on a dictionary. So it's a dictionary that has 3 keys and corresponding values. So key 1 is group, key 2 is val1, key 3 is val2. The associated values to group are A, B, B, C for val1. They are 1, 2, 3, 4, 5. For val2, they are 10, 20, 30, 40, and 50. Now that I created my data frame, I would like to print it. See here, you see that I print my data frame. So it has 5 rows and 3 columns. Column 1, column 2, and column 3. So row 1, row 2, row 3, row 4, and row 5. So we see that we are having 5 rows and 3 columns, and each row is an observation. For example, the last row is an observation of group C, and the val1 is 5, val2 is 50. Now, I would like to group based on the group column. So let me change this. I can say category. It's nicer to have the category here. So when I run, okay. So I would like to group based on the category column. I call the group by function for the df data frame. I write down the name of the column that I would like to group my data based on that. So category is the name of my column. Then I would like to aggregate the data. Now that I would like to aggregate the data, I would like to aggregate the data of the val1 sum and val2 average. Okay, so I would like to first of all group based on the category. When I group based on the category, we see here we are having AA, BB, and C. Now I'm having only A, B, and C because we're grouping them by the category. So we're having one unique A, one unique B, one unique group called C. Now, I would like to have the aggregation of the sum for A in the column val1. We see that here for the category A, we are having 2 rows, therefore 2 values for the val1, 2 values for the val1. So 1 and 2. 1 plus 2, it's 3. So we see here, because we are calculating the sum for all the values that are in the val1 column for each category. So category by category. So A, the sum is 3. For B, the sum is 7. 3 plus 4, it's 7. And for C, we are having number 5. So this is how we can calculate the aggregation of data for the sum of all the values that are in val1 category for val1 column for each category. Now, I would like to calculate the average based on each category for the val2 column. So we see that here are the values. For the category A, we are having 2 observations. And for the val2 column, we see that 10 and 20 are there. And if we want to calculate their mean, or let's say their average, we need to have 10 plus 20 divided by 2. So it will be 15. So we see 15 is here. So we call the mean function for all the values that are in val2 column for each category. For category B, we are having 30 and 40, so the sum will be 70, and when it is divided by 2, because we are calculating the average, it will become 35, so we see it here. And also for the C, the average will be 50 because we only have one value. So here we learned how to group based on the category column from the DF data frame, and how to aggregate the data for all the values in the val1 for each category to calculate the sum, and for all the values in val2 column for each category to calculate the mean, or let's say the average. Thank you for watching. Hello everyone, welcome to this video. In today's video, we are going to learn expressions with conditions, and we would like to apply them to our data frame. So we are first of all importing the polars library, because we would like to create a polars data frame. So in order to create our polars data frame, we call the data frame function from the polars library, we call it df. Then we create our data frame. So we are having two main columns, category and value. So for the category column, so the title is category, we are having the values in this category that are A, B, B, and C. So we are having the second column called value, and the values in this column are 10, 20, 30, and 40, and 50. So first of all, we print this data frame df. So we see it here in the output. We have 5 rows and 2 columns, column 1 and column 2, column 1 and column 2. And we are having 5 rows, first row, second row, third row, fourth row, and fifth row. Okay. So we see that for category A, we are having 2 values. For category B, we are having 2 values. For category C, we are having 1 value only. Now I would like to group by the category column. So I write down the group function for the df data frame, and based on the category we would like to group it. Then we are going to aggregate the data based on the value column, using the value column name, using the call function from the polars library. But I would like to filter it. How I would like to filter it? I would like to filter it in a way that only the values can be reported that are larger than 15. So we would like to calculate the sum of values for each category if that value is larger than 15. So let me illustrate it first with an example, so it's not very much abstract. So here we see that for category A, we are grouping here. This is the table that we are having after we did the group by and we did the aggregation. So we group by based on the category A, B, and C. So we are having A, B, and C. So for the group A, we only see number 20. But for group B, we see 70. 70 comes from 30 plus 40, because we are having these 2 values for the category B. But number 20 for category A comes from here. But what happened to this number? Aren't we calculating the sum? So it should be 30. No, it should not be 30. It should be 20 indeed. Why? Because we are calculating the sum of all the values in the value column that are larger than 15. So 10, is it larger than 15? No, therefore it's not included in the sum. So 20, is it larger than 15? Yes, so sum is calculated. So for A, we are having only these 2 values. One of them is excluded because it's not larger than 15. And this one is included because it is larger than 15, so the sum is 20. For the B, so for the B, we see that 2 values are reported, 30 and 40. So both of them are larger than 15, so both of them are calculated in the sum. So we are having the sum of 30 and 40, so it's 70. For the C as well, so we see that for C, we are having only one numerical value, which is 50. And 50, is it larger than 15? Yes, so the sum of one value is its own, so it's 50. But if this 50 was like 10, like if I have this 50 to be 10, so when I replace it
and I run the code, we see that for C we have 0. Why? Because 10 is not larger than 15, so it's not included. So this is how we can actually put conditions. We are putting the condition of we are going to include values that are only larger than 15 in the sum. Okay, so here I go back to 50 again, and then I use the alias function to label the column. So sum above 20, sum above 20. So the title should be sum above 15 actually. Okay, so now in this video we learned how to create a data frame and how to have expressions with certain conditions that we need to meet. Thank you for watching. Hello everyone, welcome to this video. In today's video we're going to learn about group by function and the join function. We're going to combine these two concepts. So first of all, we are going to import the polars library because we would like to create a polars data frame. Then I call the data frame function for the polars library, from the polars library, sorry, and I call it df. Okay, so I create my data frame based on two keys that are called group and values, and there are some corresponding values to these two keys. So these are the values for the key group, and these are the values for the key value. Let's say this is the first column and this is the second column, and this column name is group and this column name is value. So first of all, I print my data frame df. So we see it here in the output. We are having 5 rows and 2 columns. So 2 columns and 5 rows. 1, 2, 3, 4, 4, and 5. We see that we are having 2 groups A, 2 groups B, and 1 C. So there are 2 reported values for A, 2 reported values for B, and 1 reported value for C. Now, I would like to aggregate my data. I would like to group by the group column. Let me change the name, category. So I run the code one more time. Okay. So I would like to group the data based on the category column. So we see that we are having only one A, one B, and one C instead of having A, B, B, and C. So we group by the category column for the df data frame, and we aggregate based on the values that are in the value column, and we're going to have their average, and we name the column to be mean value using the alias function. So when we look at all of this is assigned to a data frame called groups, and we print the grouped. So here we see the output. We are having 3 rows and 2 columns. So row 1, row 2, and row 3, and 2 columns, column 1 and column 2. So here we see that we are having A, and a new column that is called mean val is added. Exactly this column that we added using the alias function. And here for A, we see that number 15 is reported. How did we calculate this 15? So the reported values for A were 10 and 20. So the sum is 30 and their average is 15, which is reported here. So we are creating a new column called mean val using the alias function, and in that column we are going to fill that column actually using the average of all the values for each category. So for category A we are having the average of 15. We do the same with the category B. So we have the category B and number 35 is reported there, which is calculated based on 30 plus 40, it's 70. 70 divided by 2, it's 35. And for C, we are having 50 because we are having only one C. And so the average equals this one. So this is how actually we are aggregating the data based on the average of the values in the value column for each category. Now I would like to join result back to the original data frame. So this is the important part. In order to do that, first of all, we see how it looks like. So we see that here, this is the original data frame, and here is the last data frame that we are joining back the mean values that we calculated actually to the original data frame. So the original data frame AA, BB, and CC, AA, BB, and C. Sorry, AA, BB, and 1C, not double C's. And the value column exactly like the original data frame, 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. This is the value column. And finally, we are having the mean value column that is added. But how we have this one? So these values, these mean values are exactly the ones that we calculated in the second stage, but we are joining it back to the original data frame. So we see that for category A, we are having the value 10 and 20, but the average is 15. So the average is reported here as a new column. For B, the same thing happens. We are having the average being reported, and for C also the same thing. But how can I do that? In order to do this, I call the join function for the df data frame, and I would like to say that, okay, join the grouped that we calculated here on the category column. And we see here we are joining what we calculated here, we are joining it in the original data frame based on the category column. Thank you for watching. Hello everyone, welcome to this video. In today's video, we are going to learn how to sort our data in our data frame. So first of all, we're going to import the polars library because we would like to create a polars data frame. Therefore, we need the polars library to be imported. In the first step, we would like to create our polars data frame with two columns, group and value. And these are the values that are going to fit in the first column. These are the values that are going to fit in my second column, which is titled value. So now I would like to print this data frame. You see that this is my data frame. So it has 5 rows and 2 columns. Column 1, column 2, first row, second row, third row, fourth row, and fifth row. So we are seeing that we are having 3 associated values for group A and 2 associated values for group B. And here, to create our data frame, we call the data frame function from the polars library to create our data frame, and we are having the name of the data frame, which is df. Now we would like to sort it. In order to sort this data frame, we simply call the sort function for the df data frame, and we are going to sort the data frame by group. The group is the title of the first column, and then by the value column in ascending order. Okay, this is going to ensure that the ranking is applied to sorted values within each group, because we are having 2 groups, A and B. And then we are having this sort function here, and then using the with columns function. First of all, we are labeling the new column that is supposed to be added. We label the new column to be rank in group using the alias function. Okay, so let me show you the output first. So you see that here we are having the column 1, column 2, and column 3. Column 1 is AAABB, so we see that we are having the same column. For the value, we are also having the same column, but the difference with the original data frame is that it is sorted. So we are having 12, 23, 33, 41, and 52. And we are having 33, 12, 30, 22 here, 23 here. You see that it's not sorted, but they are sorted here. And you see that they are sorted first based on the group and then based on the value, because we mentioned that we would like to sort firstly based on the group, then based on the value. So if we were having only based on the value, there might be the possibility of B to start the data frame. The first row was B, then A, then B again, etc. So we sort firstly based on the group, which was originally sorted as well, because we were having AAA in the beginning. AAA, BB. So first the sorted group, then sorted values. So you see that it's in ascending order. Then we use the with columns function to add a new column called rank in group. So rank in group, you see it here. So you see rank in group is added. This is the title of the new column using the alias function. Okay. So here we see that we are having for the group A, we see that 1, 2, 3, the ranks. And then again for group B, we are starting over again, 1 and 2. So rank in each group. So this says that, for example, for this row, we are having the rank 2 in the group, meaning that rank 2 in group A. Okay. And this one is rank 2 in group B. So rank in group is the thing that we are discussing here. So we use the with column function, as I mentioned. Then we are having the title of the new column using the alias function. And here we are having the rank dense. So we call the rank function, and we have the dense keyword that is going to assign consecutive ranks that are 1, 2, 3 without gaps. Okay, so we see the 1, 2, 3, 1, 2. So it's the assignment of consecutive ranks. And then we are saying that, okay, rank dense over the groups, ensuring that a ranking is performed separately for each group. So this is why we are having 1, 2, 3 here, and then 1, 2 again here, and not 4, 5. Okay, because we are having over groups. So we are ensuring that the ranking is performed separately for each group. Okay, and all of this is done for the values that are in the value column using the call function from the Polars library. And finally, we are showing these sorted ranked data frame that we see here in the output. So in this video, we learned how to create a data frame, and we learned how to sort the data frame based on the group and values columns. So we learned how to have the sorting based on 2 columns, or let's say we can say multiple columns. And then we learned how to rank the values in each group. Thank you for watching.
Hello everyone, welcome to this video. In today's video, we would like to learn about the aggregation with custom functions. So first of all, because we would like to create our Polars data frame, we need to import the Polars library as PL and make sure that it is installed on the system. So this is going to help you to make it work. You don't need to do any further steps. Then in order to create our Polars data frame, we call the data frame function from the Polars library, and we name it to be df. So df is the name of my data frame. Then we are having here the data with respect to the creation of our data frame. So here we see that we are having the category and value. For the category, let me first print the data frame so it's easier for you to see it in the output. So when I run the code one more time, we see that category is the title of one column, as you see here, and value is the title of another column that we see here. So we are having 2 columns that are category and value. Then we are having 5 rows, first row, second, third, fourth, and fifth. Okay, so we see that we created our data frame from a dictionary. So here are the keys, category and value. They are the keys, and we are having their corresponding values. For example, A, B, B are the corresponding value of the category. And then we are having the corresponding values that are 3, 1, 2, 5, 5 that are the corresponding values of the value category. Okay, now that we created our data frame, we print it and we see it here. We are having 5 rows and 2 columns, and what I need to do is to do aggregation with custom functions. So let me show you the output first. So this is the original data frame. We have 5 rows and 2 columns. But I would like to aggregate data and group the data based on the category column. So the output is a 2 row and 2 column, 2 rows and 2 columns data frame that you see here. The first column is called category. The second column now is called sum of squares, not value anymore. Okay. And we see that here we were having A, B, B, but here we are having A and B. So we are grouping the data by A and B, so we don't have the repetition. And we are having the sum of squares. For A, it is 14, and for B, it is 50. But how can we calculate this? What has happened here is the following. So we are having the values that are related to the category A that are 3, 1, and 2. So these are the corresponding values for the category A. And we are calculating the sum of squares, meaning that 3 to the power of 2 plus 1 to the power of 2 plus 2 to the power of 2. It means that 3 to the power of 2, it's 9 plus 1 plus 4. And it is going to be 14, the output. And we see that here 14 is shown there. The same goes with the B. B is having two values, 5, so they are both 5. So 5 to the power of 2, 5 to the power of 2 plus 5 to the power of 2. So we're going to have 25 plus 25, and we see that 50 is the output, which is here that we see here. So we now understand the logic behind the output, but how can we have such an output? In order to have the aggregation based on the category, let's say grouping by based on the category and aggregation of the data, we need to call the group by function for the df data frame. Data frame df is the name of our data frame. So we group based on the category column in the df data frame, and we aggregate the data based on the values that are in the value column using the call function from the polars library. And whatever that is the value in each row in the value column, we are going to raise it to the power of 2 and then calculate their sum. Okay, so 3 is, this is the first row, 3 is raised to the power of 2, 1 is raised to the power of 2, and 2 is raised to the power of 2. So they are in the same category because they are all from the A. And now that we calculated the power of 2, their power of 2, we are going to have the sum function, which is going to calculate their sum. So 9 plus 1 plus 4, it is 14. So 14 is there. And how do we choose the sum of a square, the title? We use the alias function, and we are having sum of squares. So sum of squares is the title of the column, and we use the alias function to put this title for ourselves. So now that the first category, which is A, is finished, we go for the next category. For the next category, we are having two values for B. So we are going to raise the values that are in the column corresponding to B, in the rows that are corresponding to B in the value column. So in the value column, we are going to raise the values to the power of 2 that are in the B category, category B, using the call function from the Pandas library. Once all the numbers are calculated, so 25 and 25, we are having the sum function, so we are having the sum of them, so sum of the squares, let's say, and we are having the number 50 here in the output. So this is basically how we can have aggregation with custom functions. So this is my custom function. We can raise it to the power of 3, to the power of 4. We can divide it by n, for example. So whatever we want to do, we can do it here. So this is how we can customize the aggregation. Thank you for watching. Hello everyone, welcome to this video. In today's video, we are going to learn first of all how to create a polars data frame, and then we are going to learn how to group them based on one column, and then how to calculate the aggregation of the sum, the mean, or let's say the average, the max, the mean, and the count. Each of them is going to give us certain values with respect to the original data frame. And finally, we are going to learn how to implement them together, because so far we have the examples of them being done separately. So let's dive in. Now, first of all, we need to import the polars library. because we're going to have a polars data frame, we need to import the polars library. Then in order to create our polars data frame, we call the data frame function from the polars library and we name it to be df. This is the name of my data frame. Then we create our data frame from a dictionary. So dictionaries are key value pairs. So we're having the group and value as the keys, and these are the values corresponding to each category. So let me first of all print the df data frame. So we see it here. So we see that the group and value, these are the columns. Group and value, these are the name of the columns. So this is the original data frame, okay? We have two columns that we see the number 2 here, and 5 rows. First row, second row, third row, fourth row, and the fifth row, okay? And in the group column, we are having A, B, B, and C that we see here, A, B, B, and C. And for the value column, we are having 10, 20, 30, 40, and 50. So we are having a data frame with 5 rows and 2 columns. Now that the data frame is created, I would like to first start with the aggregation of the data for the sum function. So when I run the code, first of all, you see C, A, and B. So we don't see the repetitions because we are grouping based on the group column. Okay, we're grouping the first column based on the A, B, and C. And then we would like to aggregate the data based on the value. So here we see that for the group A, we are having number 30. So when looking at the original data frame, we see that A has 2 corresponding values, 10 and 20. So 10 plus 20, it's 30. So we have the sum of the values. B, the same thing, we are having 30 and 40. So we have the 70 here. And for C, we are having number 50 here. Okay. So now the second data frame is going to have the sum of the values for each group, for group A, for group B, and for group C. But how can we do that? First of all, we are going to have the group by function for the df data frame, which is the name of our original data frame, based on the group column, and we are going to aggregate the data for all the values that are in the value column using the call function from the polars library, and we are going to call the sum function that is going to calculate the sum of values that are inside the value column for each group. Okay, so for each group, for group A, for example, the sum of the values that are in the value column are calculated and put it here. Okay, so this is how basically the first data frame, the second data frame is done, because the first one was the original one. Now if we want to have the average, what about the average? So we see here, for example, for A, we are having number 15, which is the 10 plus 20, it will be 30 divided by 2, it is 15. For B, we are having 35, so B, we see that 30 plus 40, it's 70 divided by 2, so 35 is there, which is the average value. And also for C, we are having 50 because we are only having one value for the group C. Now, how can we do that? Again, we are going to group based on the group column for the df data frame, and we are going to aggregate all the values that are in the value column based on their average and assign it to the df mean data frame, and we print the df mean data frame, and we saw it in the output. So now that I comment this one and I go for the next one, when I run the code, we see that here for the column A, we see number 20. For column B, we see number 40. For column C, we see number 50. But what is these numbers? What are these numbers? For column A, number 20 is reported while we were having the 10 and 20. So here we are reporting the maximum value in each group. And in group A, the maximum value is 20. Why? Because we are having 10 and 20, so 20 is the max value. For B, we are having 30 and 40. And we see that 40 is reported here, so 40 is the max value, and for C it's 50 because we don't have any other number for C. So again, we are going to group by based on the group column and aggregate the data for all the values that are in the value column, and for them we call the max function. So it is going to report the maximum value. All of this is assigned to the df max data frame, and we printed the df max data frame in the output. Then in order to find the minimum, basically we are going to do the same thing as we did here, but instead of having the max function, we are having the min function here. So when I run the code, we see that here for A, now we are having number 10 being reported. For group A, we were having two values, 10 and 20, but you see that 10 is there. Okay. For B, we are having 30. So 30 and 40 is reported, so 30 is reported because 30 is the minimum value. And then for C, we are having number 50, which is here. Okay, so this is also how we can report the minimum. When I comment this part and go for the next part, and when I run the code, first let me show you the output. It says that for C, the number is 1, for B, the number is 2, for A, the number is 2. But how it is calculated and what this number is representing. To be clear, we need to see how many numbers are reported for each category. For category A, we are having two numbers being reported, 10 and 20. For category B, we see that two numbers are also reported, 30 and 40. So we see that number 2 is there. And for category C, let's say for group C, we are having only one number being reported. So this is why we are having 1 here. Basically, we are counting the numbers that are reported for each group, and we are putting it here. But how can I do that? Again, we do all the same thing, but instead we are having the count function being called at the end. So it is going to count the numbers that are reported for each group. And all of these things are being done separately. So we saw that we are having a new data frame for the minimum, a new data frame for maximum, a new data frame for the count, for a new data frame for the, let's say, for the average, and for the sum. But how can I do everything in one data frame? So I would like to create a new data frame with all of this data together. In order to do that, here, let me run the code. We see that we are having the group, okay, A, B, and C, and we are having all the information that we were looking for: sum, mean, sum, let's say mean, which I mean it is average, and then the minimum, the maximum, and the count. Okay, and this is reported for each group. You see, everything that we've done separately now is done in one data frame. How can I do that? I call the data frame function for the df data frame, and we're going to group it based on the group column, and we're going to aggregate the data, and we have the new column being created that is called sum using the alias function, and the sum of all the values for each group is calculated and assigned to the sum column. Okay, for A, for example, we are having number 30, which is calculated based on 10 and 20. Then we are having the new column being created: mean, the minimum, the maximum, and the count. So all of these things again are being done, but they are assigned in one only data frame, and that is called df stats, and we're going to print the df stats in the output. So we see that here we are having the one unique data frame with 3 rows and 6 columns that are grouped based on the group column, so A, B, and C, and we see that the statistics for each group is calculated. Thank you for watching. Hello everyone, welcome to this video. In today's video we are going to learn about left join, right join, inner join, and outer join for a polars data frame. So first of all, we import the polars library because I would like to create a polars data frame. Then in order to create a polars data frame, we simply call the data frame function from the polars library. I call my data frame to be first. This is the name of my data frame. And there are 2 columns in my data frame. The first one is ID. The second column is name. So we're having a column called ID and a new column called name. In the column ID, we are going to have these values. In the column name, we are having to have this information. So there are some names. So we know that the person with ID 1 is called Alice. The person with ID 2 is called Bob. The person with ID 3 is called Charlie. So let's go and see the output of the first data frame. We see that there are 3 rows and 2 columns, ID and name. So these are the 2 columns. And we are having 3 rows, the first row, second row, and the third row. So we know that the ID of Alice is 1, the ID of Bob is 2, the ID of Charlie is 3. So now I would like to create a second data frame. I call again the data frame function from the Polars library and call the data frame to be second. Again, we are having new columns. So here we are having a column called ID and a column called score. And we see that we are having 3 values for each column. For the ID, we are having 2, 3, 4. For the score, we are having 85, 90, and 95. So when I print the second data frame, I see the output here, 3 rows, 2 columns. Columns are ID and score, and 3 rows. First row, second row, and the third row. So we see that the person with ID 2 has the score of 85. The person with ID 3 has the score of 90. And the person with ID 4 has the score of 95. So these are the 2 data frames that we are going to work with. Based on these 2 data frames, we are going to learn how to have the left join, the right join, inner join, and in the end, outer join, or let's say the full join. In order to have the left join, we call the join function for the first data frame. So the name of my data frame is first, so we have the first here. Then inside parentheses, we would like to have the join on the ID, because this is what is shared between these 2. ID is in both the data frames, okay, ID and ID. So this is a column that is shared for both data frame that exists actually in both data frames. So we would like to join based on ID, and I would like to join based on the first data frame. So I would like to join the first data frame to the second data frame. So the second is there. How I would like to do that? I would like to do a left join. Okay, so it is going to keep all the rows from the left. Okay, so when all of this is assigned to df left join, and we print the df left join. So when looking at the output, we see that here all the IDs that are for the first data frame is there. So 1, 2, 3 is there, 1, 2, 3. But 2, 3, 4, the 4 is not there. So all the IDs that are in the first data frame is shown when we are having the left join. Why? Because we were having the left join based on the first data frame. So we first said that, okay, we would like to join on the first data frame. And what we would like to join on the first data frame? We would like to join the second data frame on the first data frame based on the ID and using the left join. So when looking in the output, we see that all the IDs of the first data frame, they are there, 1, 2, 3. The names are there, Alice, Bob, and Charlie. Again, this is the information from the first data frame, Alice, Bob, and Charlie, so they are reported there. And for the score, we have a score column that we didn't have in the first data frame. As you see here, we didn't have any score column. Score column is for the second data frame that is going to be joined actually to the information of the first data frame. So when we look at the score, we see that for the person with the ID 1, whose name is Alice, we have no score. This is a missing value. Why? Because in the second data frame, we were having ID 2, 3, and 4. We were not having any information with respect to the ID 1. So this is a missing value, and we are going to put null there. Okay. Then we are having the Bob with the ID 1. The 85 is his score. 85 comes from the second data frame. So second data frame, we see that for the person with ID 2, we have the score of 85. So it is reported here. Also ID 3, the name is Charlie, so the name is taken from the first data frame, and the score is taken from the second data frame. Sorry, this is the one because we're having the ID 3. So 90 is reported there as well. So now we learned about the left join. Okay, so what if I want to have the right join. So if I want to have the right join, I'm going to again call the join function for the first data frame and join on the second data frame based on the ID and how I would like to have the right version. Looking at the right version, we're going to have all the information that is in the second data frame actually. Okay. Now I have the Bob and Charlie. So Bob and Charlie, they are both there. Bob and Charlie, they are both there because the ID of the 2, 3, and 4, they are reported here. 2, 3, and 4, they are reported here. Okay. And their scores also are reported. So we see that ID2, ID3, and ID4 is reported here. ID2, 3, and 4. So all the information in the second data frame is reported here. But for the name, we are getting the name from the name column of the first data frame. And we are having Alice, Bob, and Charlie for the ID 1, 2, 3. So ID 1 is not here. I would like to have ID 2, 3, and 4 only. That's it. So for ID 2, we have the Bob there. So Bob is reported here. For ID 3, we have the name Charlie is there. So Charlie. But for ID 4, we don't have the name. So it's a null. We don't have the name of the person with ID 4 because here we are having ID and scores. So ID 4 has a score of 95, which is reported here. But the name is not there. This is a missing value. So this is how the right join is working. And if I want to change it, so now I would like to have the inner join. Okay. So run the code. We are having the join function again for the first data frame based on the second data frame on the ID. And now how we would like to have the inner. The inner join is going to help us to have only the shared information among two data frames. So we are having ID 1, 2, 3. We are having here ID 2, 3, 4 for the first data frame. 1, 2, 3 for the second data frame. 2, 3, 4. So 2 and 3, the IDs 2 and 3 are the IDs that are shared between these two data frames. Okay, in inner join, we are going to work with the shared data among two data frames. So we are having the ID 2 and 3, they are reported. Their name are Bob and Charlie, which is taken from the first data frame, and their scores are 85 and 90, which is reported from the second data frame as we see it here in the output. So this is also about the inner join. Finally, we're going to learn about the outer join, or let's say the full join. And this means that we're going to have all the information of the both data frames. Okay, we're going to call the join function again for the first data frame based on the, and we're going to join the second on the first one based on the ID and how we would like it to be full, and all of this is assigned to the df outer, and df outer is being printed. So looking at the df outer, so when I run the code, this is the, let me comment the inner join, commenting the inner join. So when I run the code now, okay, when I run the code now, we see that the ID, the column ID is there, which is shared between the two data frames. The column name is there, which comes from the first data frame. The column ID right is there because this comes from the IDs that we are having from the second data frame. So 2, 3, and 4, 2, 3, and 4 is there. Okay. And then we are going to have the score column coming from the score column of the second data frame. So here, when we look at the first two columns that they come from the first data frame, we see that number 2, 3, ID 2, 3, and 1 is reported there. And there is one null value in the ID. Okay, because number 4 is not existing actually in the first data frame, but it exists in the second data frame. So we see the missing value there because we don't have it. But in the ID for the second data frame, we see the number 4 is reported. Okay, so 1, 2, 3 is from the first data frame and their name is there. So Bob, Charlie, and Alice. But again, we don't have this data for the first data frame. Looking at the second data frame, we have the ID 2, 3, and 4 with their corresponding scores, and this person Alice, which is Alice in the first data frame, we don't know its counterpart ID in the second data frame. It must be 1, but because it's a missing value, it's null, and the score of Alice is also null because we don't have any information in the second data frame for the Alice. So looking at the data frame here, at the full join data frame, we see that Bob has the ID 2 in both data frames, which is correct, and the score is 85. And Charlie has the ID 3, score is 90. There is one person with ID 4. We don't know the name of this person, but this person scored 95. And we know that Alice is the ID 1, and it must be ID 1 here, but because it's a missing value in the second data frame, we have the null, but we don't know the score of Alice, so it's also a missing value. So this is how actually we can have our data frame in the output, and we see that here if we write outer, it is going to give us the same data frame as well, but it is recommended to have the full instead of the outer. Okay, so in this video we learned how to have the left join, how to have the right join, inner join, and outer join, or let's say the full join, and we learned their differences. The left join is going to have all the information of the first data frame. The right join is going to have all the information of the second data frame. Inner join is going to have the shared information among these two data frames, and outer join or full join is going to have all the information in both data frames. Thank you for watching. Hello everyone, welcome to this video. In today's video, we're going to learn about vertical concatenation for Polars data frame. So first of all, we're going to import the Polars library after its installation. Then we need to create our Polars data frame. So here we're creating the first data frame here, and here we are creating the second data frame. We call the data frame function from the Polars library, we call it df1, and we call this one df2. We are having two columns, the ID and name, and two columns again here, ID and name. So the column ID in the first data frame has the values 1 and 2, and the name column has Alice and Bob. Here we are having the 3 and 4 as the ID, and name for is having the Charlie and David. So let me print the df1 and df2 firstly. So df1, this is the df1, we are having ID and name, so two columns, ID 1 and 2, Alice and Bob. So we see that ID 1 is for Alice, ID 2 is for Bob. Now looking at the data frame 2, we see again ID and name, and we see that the IDs are 3 and 4, and Charlie and David are the names. So ID 3 is for Charlie, ID 4 is for David. So we saw that the data frame is being well structured, well constructed, and well printed. Now we would like to do the vertical concatenation. It is going to add rows. So let me show you the output first. The first one, the first data frame, has the 2 rows and 2 columns. The second one also has 2 rows and 2 columns. Now what if we want to have the concatenation, vertical concatenation? So we see that we are having the same number of columns, 2 columns are there, ID and name, but 4 rows are there instead of having 2. So first row, second row, third row, and fourth row. And we see here IDs are from 1 to 4 rather than 1 to 2 and 3 to 4, and all the names are there. So ID 1 was for Alice, we have the ID 1 for Alice, ID 2 was for Bob, so Bob is there. So we see that here we are having the concatenation, a vertical concatenation of the 2 data frame. But how can we reach to this vertical concatenated data frame? Basically, vertical concatenation is going to help us to add rows. So you see that here we were having 2 rows, here we were having another 2 rows, but here we were having 4 rows. So we are adding the rows. In order to do that, in order to have the vertical concatenation, simply we are going to call the concat function from the Polars library. We are going to have the concatenation over the df1 and df2, so the first and the second data frame, how we would like to concatenate them in the vertical manner. So we are assigning all of this output of the data frame to a data frame called the df vertical, and we're going to print it. And we see the print here in the output. So basically in this video, we learned how to have the vertical concatenation by adding rows. And in order to have the concatenation, we call the concatenate function from the Polars library, and we mentioned that we would like to have it vertical. Thank you for watching. Hello everyone, welcome to this video. In today's video, we are going to talk about horizontal concatenation. So first of all, we are importing the Polars library, and we firstly need to create two data frames, df3 and df4 we call them. To create them, we call the data frame function from the Polars library. We are having one column here called age, and we are having two rows because there are two values for the age column. And here we are again having one column and two rows, Montreal and Toronto. So these are the values in the city column. So let me print these two data frames. So the first data frame is the age column with two values. The second one is the city column with two names like Montreal and Toronto. So we see that we are having two data frames. Now we would like to horizontally concatenate them, meaning that we would like to add columns. So this one has one column and this data frame has one column only. And we would like to concatenate them in order to have two columns, age and city. So 25 Montreal, 30 Toronto. So now that we would like to do this, we can simply call the concat function from the Polars library. And we would like to concatenate over the df3 and df4, so our two data frames that we just created. How we would like to concatenate them? We would like to do horizontal concatenation. So we type down horizontal here, and all of this is assigned to df horizontal, our new data frame, and we print the data frame in the output. So we see that here the concatenated horizontal concatenation is performed very well. Thank you for watching.